record on this computer. Good evening, everybody. I'm Peter Morris. This is the Comanche Zoom for July 30th. We are on Thursday night. We're to have the topic tonight of the ElectroAir Electronic Ignition, and it should be a lot of fun. At this point, if you want to say something, just key your mic. In other words, unmute your mic, say what you want to do, and come on back. The general idea is to introduce yourself, say who you are, where you are, and what you fly. So have at it.
Hi, I'm Terry Lindsay in Whiteman Airport, Los Angeles, California, and I fly a 260B.
Welcome.
Dan Homiser, Kenosha, Wisconsin, with a 250.
Chris Burnley, Belmont, California, 260B.
Hi, it's Don Bell up in Calgary in Canada. I have a 260C turbo.
Wow. Welcome. This is about the only way you can attend to fly-in the U.S., huh?
What's that?
This is about the only way you can attend to fly-in the U.S.?
Yeah, well, actually, it's no problem flying down there. We've been down a couple times.
Well,
an airplane
as I understand it, you can't get across the border right now.
No, it's fine in an airplane. You can't in a car, but I'm going back and forth in an airplane.
For us.
Well, cool. We had a couple of people from Quebec that were complaining that they couldn't attend the fly-in that we just had.
Well, they could.
Well, actually, they could. There's no restrictions for airplanes.
Well, that's good to know.
I didn't know that. We hopped in the helicopter and flew down there, and it was no problem at all.
Anybody else? Jump in, who you are, where you are, and what you fly.
I'm Bernie Stumpf. I'm in Westerly, Rhode Island, and I fly a 260B that I got in 1995, and it's still doing great.
I suppose I should do mine too. I'm Pete Morris. I have a new to me 250, 1963 250, and I fly out of Danielson, Connecticut.
I'm Gil Kessler, fly out of Culpeper, Virginia, and I fly a Comanche 260. 8 mile, I guess.
So I'm Craig Hammond out of Fort Sill, Oklahoma, Lawton Fort Sill. And 1960 250, had it since 2003. And last year I put in ElectroAir system. And I'm very pleased with it, getting about 2 gallons of an hour savings and with the same horsepower. So,
way to go.
Yeah.
Way to go.
Hey, CJ, I'm going to change your name.
That would be great. And I'm CJ. I fly a 180 and my father's 260B. We're ordering the ElectroAir for the 260B. We can't wait to get it in. We've heard so many great things from all of you. So the airplanes are based in Montpelier, Vermont, and Westerly, Rhode Island. I think Dad may speak. So thanks, everybody. We had a spot of car trouble versus airplane trouble, by the way. Sorry to join a few minutes late. And go over to anybody else who wants to say who you are, where you are, and what you fly.
Better car trouble than airplane trouble.
see. And Bob Capiello, what's happening in your Comanche neighborhood? If you can unmute.
Okay, you're picking on me.
I
Southern California. I live in Santa Clarita and tenant at Whiteman Airport. And I've got a Comanche single 260, 1965. I've had that one for about 16 years now. And then I've got the PA 30 69 C model that I picked up. I bought it as a basket case and ended up rebuilding it. And I don't know if you can see it, but I think it's behind me in the photograph or in the video or whatever you want to call that.
Yep.
I was gonna say, if that is your basket case, you sure transformed her. She's beautiful.
It took 3 years, actually 2.5 years right now. It took me a year to get it running and about another 4 months to do the new panel. And then after that, it was time to get my twin rating. That took a couple months, a little more than that maybe. And I've been flying it now. I've got to do my second annual inspection next month. So it's been flying for 1 year. First annual inspection, then we flew it for a year. Now it's time to do it again. So
well done, sir. Spectacular.
Yeah, it's a fun airplane to fly. Honestly, I was expecting it to be faster, but in reality, my single engine Comanche below 10,000 feet is faster by a couple miles an hour than the twin, and it will also carry more weight than the twin. And you know, the safety margin built into the twin kind of cuts down on your gross weight. But yeah, I like the twin. It's a little more complicated, a little harder to fly, and a little more challenging, and I kind of like that.
I just love that you've got his and hers.
Yeah,
well,
there you
welcome.
go.
Thanks
There
for
you
being
go.
here.
All right. Yeah.
And
my buddy Terry, I think, is next. If he's still online here, you got Terry Lindsay there?
Yes,
If you got Terry Lindsay, put him on the spot.
Myself.
There he is. There he is. That's my buddy Terry.
There we go.
Terry,
well, Terry, how are things in your Comanche neighborhood? What are you flying? Where are you from?
Terry, I think that might have been for you.
I didn't hear what you said.
Oh, sorry, Terry. I was saying, how are things since you've been outed? How are things in your
I fly at the
neighborhood?
same airport as Bob.
Nice. What do you fly?
He's the king of the Comanches at Whiteman.
Well, welcome aboard. Thanks for being here. Who do you want to out next of the folks you know, or do you want me to just pick somebody?
Terry's keeping awful quiet today. I don't understand that. He's usually talking to.
Well, there's so much talk about people with multiple Comanches, I felt kind of like I was outclassed. Also, Bob, your face is all fogged out. You can barely see it.
Wow. Let me see if I can clean the lens.
Yeah, he looks like a bank robber with a stocking on his face.
It's that new COVID look we've all got. I walked into a bank the other day and I thought, man, 6 months ago, if I walked into a bank wearing a bandana, they'd be calling the police. Now, if I don't, they're calling the police. Well, David, since we got you, you want to introduce yourself, say who you are, where you are, and what you fly? Sorry, David, that was for you. I think I'm having some technical difficulties here.
Sorry, trying to get a bite to eat here. Dave Byers got a PA-24, you can see in the background there, 1958, Packard Cowling, and based in Columbus, Indiana. And CJ's based in Seymour, obviously.
I was there for an extended annual. I think we did every AD under the sun for the PA-28. Good to see you. Thanks
Good
for
to
being
see you.
here. And everybody, feel free to jump in. I don't usually call on victims, but if you're here, just grab a quiet spot like you do in ATC and say who you are, what you fly, where you're from.
Guard.
It's Don here again from Calgary. I wanted to point out on my 260 turbo, I've had about 6 Comanches. This is my latest one. I've owned it for a number of years. I bought it from the original owner and out of California. It's the twin turbo version that they made a few of them, a 1972 model. I think it's the 6th or 7th from the last Comanche ever built. And it only has 1,800 hours on it total time. And I did a very extensive renovation or rebuild. Everything firewall forward with these are newer rebuilt, and all the avionics were redone and new paint job. I've flown multiple types up to a 737. I'm current on a captain on a Boeing 737. Also fly helicopters, currently flying A-Stars. But I got to admit, the Comanche is still my favorite airplane ever. I'm in love with the thing and can't get enough flying it. I think my wife and I are going to go fly somewhere in the mountains tomorrow and find a place to overnight and have lunch. And beautiful machines. Can't wait to hear about this ignition. I've thought about it, and I think I hope it works on the turbo version because I'd really like to move on with it.
Well, thanks for being here, Don. I have to say, I was going to say, I bet you say that to all the planes, and then I realized when you started to go on, you really meant it. So we approve. It's an honor to hear somebody with your experience say that. I do have one exciting thing to say. I know we're a little early on, but the good news is that ElectroAir is doing an amazing special, but they have just sweetened the deal just for us Comanches, and we'll be posting that information just after this session. So stay tuned. It's going to be exciting. We sold them out of product last year. It was really fun to have Darrell call me and be like, who can wait? I'm out. And I know that we've gotten some pretty happy Comanche drivers who've installed it before. We're happy to have them here tonight. That's all I'll say on that matter. If you're here, jump in and just say who you are, where you are, and what you drive. And you'll need to unmute to talk and then remute again. Otherwise, it picks us up and it blocks others.
Well, that's interesting. Well, I don't know if you can hear me. I'm Dave Gittleman. I'm in sunny Florida where we're currently having a thunderstorm. I fly a 180 Comanche, which I've owned for 51 years. And that's my story. I'm sticking to it.
Dave, so happy to have you. Dave Gittleman has supported many people with superb technical support for many of those 50 years. So Dave, thanks for being here and thanks for all you've done to keep us all flying safely.
Thank you.
Welcome.
It's kind of you to say.
It's honestly said. I appreciate all that you've done for all of us. You, Zach Grant, there are so many people more. Just agreed
Morris
to
here.
come.
I'm gonna break in with my commercial message. This is just to let you guys see what's going on with the website and all that kind of stuff. This is the Comanche website, the Northeast Tribes Comanche website. As you see up at the top, it's the northeastcomanche.org. On this website, there's all those different things that's at the top there. And what I want to highlight for you real quick, we have the fly-in schedule. And we really actually have had fly-ins. The Resnick Airport one we did, and the Katama we almost did. Well, we got fogged out. We went to about 5 different airports instead. The next one we're planning to do is Sky Manor in August, and that's our typical annual meeting and end of voting and stuff like that. Yeah, here we go again. I can't get at it. Oops. I didn't mean to do that. I got to go back and do this over again. Hang on. Tell you what, go ahead and chit chat for a bit while I fix what I tried to do.
Okay.
You know, it's funny, I do, in business, I do a lot of Zoom calls, and this is typical. People don't like talking on Zoom. Maybe they get stage fright or something.
I think they do sometimes. It sort of depends on the night. We've had people just slamming in. Do we have anybody on tonight, by the way, from Australia?
Okay, I'm ready to go back and try and share things again. This is back where we were before. The problem is I couldn't get at the menus at the top. The Comanche Zoom. This is the list of things that we're hoping to do in the near future. No particular order. The only one that's right is the top one. And then down lower on the page now, it's all on the same page. These are the ones that have been recorded. And so for instance, the owner produced parts thing, if you click on this link over here, you will get to see the video of that particular Zoom. Or if you want to get the most from your engine by Steve Ells, click on that link and you get that. So that's the sales pitch I wanted to do. There is also, on the website, there's a form for registering for these Zoom things if they are available, like the one down here at the bottom with the double asterisks, and up here, New Life for Old Autopilots. There are Wings credit available. And if you register so that we have your name and email, we can make arrangements to have the Wings credit get to you. So that, you know, if you need to do, if you want to get the Wings credit, then you need to register in order to get, you know, to be able to do that. Here we have, this is the registration form. Looks like that, simple as that. There's a drop down thing of all the different ones we're going on. If you fill in, since it knows who I am, you fill it in, do that thing. If you want Wings credit, click it. And if you want to be added to the email list, click that. Right now, we haven't been doing any mini clinics because we can't get together physically, but that's wherever. And if you want to make a make a request or add a comment or something like that, you can do that. When you click send, this will come to me and I will distribute it as necessary, collect them all together and whatever. And that's the end of my sales pitch.
Pete, I do not see the July 30th link being available today on the website.
It should be there on the registration. Yeah. Tell you what. I will show it to you again. There it is, right there. July 30th, ElectroAir Ignition. And it's down the list, but that's the one that is comes up automatically. Okay? We got about 10 minutes till it's showtime.
Hey, Bernie, you're not unmuted right now in case you're talking. I think I see you talking.
Okay, can you hear me now?
Yes.
Okay, I went to the Northeast page, the Zoom links. The last one is July 23rd. I do not see the July 30th.
try refresh on your website. Yeah, sometimes the web browsers are too smart. They remember where you've been and they send you, they save that page and give it back to you. And it's a lot faster than having to read it every time. But if the page has been changed, the only way you see the change is if you refresh the browser.
Yep. Sorry, everybody, to disappear for a moment. I just made a terrible discovery, which is I had been using an actual computer instead of a smartphone to post the event on Facebook. And it looks like it never posted. So I've got a bunch of people texting me going, we just found out about this. How do we get in? I'm back. So Gloria, welcome. You want to say who you are, where you are, and what you fly?
Oh, sure. Can you hear me? Because I can't, for some reason, get the audio on my computer, so I'm calling in at the same time. So can you hear me?
Oh, yeah, you're loud and clear. Some of the best
good.
audio we've
Okay.
heard.
So I fly a 180. I'm glad to be reflying my 180. I'm from home base is Mike Gulf Juliet. It's good to see some familiar faces on the screen. So let's see, what more can I tell you? I've been flying for about 17 years, amazingly. You know, just starting again to, after having a new engine, overhauled engine, I should say, put in, I've been 10 hours on a brand newly overhauled engine.
Way to go. Thanks for being here tonight, Gloria.
My pleasure.
How are you doing on your struggle with the IFRs?
Well, it's such a blessing right now because to break in the engine, I really can't do IFR training. So I just finished writing about what a pleasure it is to just fly VFR. No foggles, and it's been beautiful. So it'll resume, I guess, in the fall, but right now I don't miss it one bit.
I love it. And Gil, I'm going to tap your shoulder to tell us who you are, where you are, and what you fly. Welcome. I think that's Gil Keating. Oh, there you go.
I'm Gil Kasser. I'm it's Gil Kasser. Is that you trying?
Welcome, Gil. I think your audio muted again.
Well, in the meantime, Phil King will talk. Hi, I'm Phil King. I'm from near Kansas City. Fly a Comanche 250. It's a 1960 model, and it's there are 6 of us in a club that fly it regularly. I've been a member of the club since 1990 and have been flying it for quite a few years. That's about it.
Phil,
welcome, Phil.
Phil, what's your
Thank
answer?
It's 6424 Papa.
I had 6632.
Welcome. And actually, just a quick question. Phil, you're obviously a part of a working club. And in others, if you've been in that long, something's going right. And there are a lot of people who fly Comanches in partnerships and clubs. We've been wanting to put together a Zoom on how to do that and make it work. Would you be willing to let us connect with you to, you know, learn from your situation?
Sure. I'd be happy to, but we've been blessed with a lot of good members who you know, they argue about who will relinquish their time slot for the other guy. So we've been very fortunate, and it's a happy group.
Knowing when you're blessed is one of the best things in life. Well, welcome aboard. Thanks for being here.
You're welcome.
Anybody else flying a Comanche in a club or a partnership? I'd love to have you jump in and introduce yourself and where you're from.
I was just noticing out there, it looks like everybody so far is at least 60 or older, and most guys, if they go out in the sun, will get the top of their head burned. Is there anybody actually younger with Comanches?
One of the people I tried to reach for tonight is Zach Mabry, who flies, he's a 20-something-year-old. He's got ElectroAir in his twin. At the Comanche towns, we've tended to have entire rows of people under 30 years old. In fact, we call them our 30 under 30s. Zach's, I was trying to reach him, and he's been traveling a lot lately, strangely, because he's flying his twin around with ElectroAir at 11 gallons per hour lean of peak, and he is happy as a clam. So they are out there, and they're running around, but they call themselves the Millennial Wings, a bunch of them, and they mostly communicate by Instagram.
When you say 11 gallons an hour, are you referring to each engine?
That's total.
Total. That's
Yep.
only 5.5 gallons per side.
You're talking about
That's pretty respectable.
I thought I'd heard him wrong the first couple of times, but no, we did a big roundtable at ComancheTown. It was kind of fun because Mike and Darrell are engine performance hackers. I mean, ElectroAir is an amazing system, but we were all talking about how to get our engines that last little bit, to make them go faster or more efficiently. It was a great roundtable, and it's part of what I'm hoping will happen tonight. Hans, over to you.
Hello, everyone.
And you are flying what, Hans? Because you've got something special there.
Hi, CJ.
Hey, Hans, how are things in your neighborhood?
Fine.
Your Comanche neighborhood.
Great. I went up flying this morning. It was great.
And what are you flying? Because I believe you've got something good.
Excuse me?
So are you flying? Because
Yeah, this morning I was flying in the 260 44 Papa.
You are a blessed man.
I couldn't hear you on that. It sounds a little, something's wrong with, I can't hear too well.
Probably my end, Hans.
Okay.
I was saying welcome aboard, and you're a blessed man flying that airplane. We're so happy.
Thank you. Me too. It's keeping it in the family.
Absolutely. Do you want to tell a little bit why 44 Pop is so special, Hans?
Sure. Okay. Well,
what's our history?
Yeah, just belonged for a long time to our good, Comanche friend Alex Sawaski, and he flew that plane around the world. He was like the 50th person to do that back a couple decades ago, but besides that, many other cross-country trips. So it's a great plane.
Oh yeah, well, welcome here, and it's 7:30. I'm going to turn this over to Pete to introduce Mike and Darrell, but before we do that, I just want to say that I looked it up, and 6 of the first 50 people to fly airplanes around the world, at least on the list I looked at, flew around the world in the Comanche.
Wow.
Pete, over to you.
All
Yeah,
right.
amazing,
Yeah.
isn't it, everybody? So Pete, you're on to introduce Mike and Darrell.
Okay, I've just now muted everybody, and what we're going to do is start the presentation from ElectroAir. I would suggest for those of you that are looking on a computer for sure, go to up at the top and click on speaker view. That way, when they share any images or something like that, that'll be big on the screen, and you will see the person who is talking instead of seeing a whole bunch of faces. So I would suggest that. We are going to be using the chat window to put in questions. If you want to ask a particular question about something, go to the chat window, type it in. When we're done with the presentation, CJ generally goes through the list one at a time, and we discuss each one as it comes up. The main reason for that is because people who are coming in on the phone don't get to see the chat window. So they need to know what the question is before we start answering it. Okay, does that make sense? So if we go to the speaker view, and I'll hand it over to the ElectroAir folks. You'll have to unmute yourself and then you're good to go.
Well, Pete, thank you very much. My name is Mike Kobylik. I'm president and one of the owners of ElectroAir. Darrell Poole, who is our head salesperson, I think he'll be joining us in a little bit. Oh no, I see him on there. Yeah, no, I see him there. Well, again, my name is Mike Kobylik. I'm from ElectroAir, president, one of the owners. I'm going to go ahead and see if we can't share the presentation. This one? Mm-hmm. There we go.
You're up.
How do I start my slideshow? Yeah. There we go. And for an extra added benefit, I think you get the benefit of my 9-month-old puppy in the background. She's a lab Stafford Terrier mix, probably terrorizing the neighborhood.
The squirrel there.
Without a doubt, there's a squirrel or a groundhog. ElectroAir has been building, as you guys, well, this is going to be a fun presentation because many of you already use the system and have made some really high compliments about how the system performs, the impact it's made on the airplane, and all of that. I just, frankly, I can't thank you enough for the very kind words. The Comanche Group has been the Comanche community has been a very loyal following of our product since we've been approved, since we earned our first STC in 2011. And we're very, very grateful for your support. ElectroAir has been flying higher, farther, and faster for over 28 years now. We started, actually a gentleman in Chattanooga, Tennessee by the name of Jeff Rose started this business in his basement and taking hot rod ignition systems and adapting them to aircraft engines for a wide range of experimental applications. In 2005, it moved from his basement to my basement up in Michigan. My partner, Pete Berger, and I, we purchased the business primarily because we saw the ignition system that he had was mature enough and was ready to go what I would call for prime time, for FAA certification. And my background, or had some background with doing a fair amount of certification work with Diamond Aircraft at the time, and it seemed like a logical step forward for the ElectroAir system. And of course, it fulfilled every traditional STC program that I've ever been involved with. And you ask yourself, what does it take to get an STC? It takes a lot of time and a lot of money. And this one was similar in that it took a fair amount of time to be able to do it. Right out of the gate, CJ sent over a testimonial today, and like I said, we've already been hearing from many of you about how the system has impacted your own particular airplane. From a Comanche 180 driver, after he installed the system on his airplane, his climb rate got better by 100 feet per minute. His cruise around 5,000 feet improved by 5 knots. His fuel consumption around 5,000 feet was down by 2 gallons per hour. Things that I didn't include in the slide is that the system allowed him to look about 20 years younger. It was also able to make him leap tall buildings in a single bound. You know, these jokes work so much better when you're in person. The Zoom stuff where it's silent is hard. Anyway, that's what we call performance gains. And we promote this system and really advertise this system as a performance enhancement to your airplane. It's not your typical, as we would call it, it's not your grandfather's Magneto. This is a real system that will start to pull out and start to optimize the things that you can do with some of these aircraft engines. We are certified on, at this point, a little over 500 aircraft models. We do both certified and experimental aircraft engines. Again, like I said, we've been around for a little over 28 years, so we've covered quite the range of aircraft applications and engine applications. Typically, when we start a question or we start the discussion about what an electronic ignition system is going to do for your airplane, we ask you what's your expectations of an electronic ignition system. We all kind of come at this from a variety of angles, but typically it's based on what many of us have seen in the automotive industry. Somebody noted the average age of the group here, so we remember moving from cars, particularly cars that use leaded gas, to unleaded fuel, and cars that had a set of points and condensers through a distributor that if you had a problem, you reached out and you squirted a little WD-40 and you cleaned them out. In the late 80s and through the early 90s, the automotive industry essentially transformed powertrain systems because they had to address things like unleaded fuels. They had to address things like higher fuel economy standards and all of that sort of thing. What they came up with were coil pack, high energy coil pack ignition systems that had computer controlled variable timing. As the control modules got more sophisticated, they controlled or looked at various inputs such as mass airflow, throttle position, a whole range of things, and plotted it out to optimize what you can get out of these engines. So instead of having a Pontiac 427 tri-power where you just dumped a bunch of gas in it to make it go faster, you had a 4-cylinder engine with a very sophisticated engine control system that could actually keep up with that GTO. Hard to believe. For many of us, we want our airplane to go from this to this. Now, I wish I could promise that for everybody, that we could put a system on the airplane that would make my little 150 there with a 100 horsepower 0200 get enough power that it would shove you into the back of your seat and light your hair on fire, so to speak, if we recall from a particular movie. Can't quite do the F-18, but we can get a good poke of the way there and a good bit more performance out of your air-cooled engine. In order to do this, we need two things, two very specific things. You must have a high energy ignition system. There's no question about that. You want the high energy to be available to combust that complete fuel air mixture completely. The second thing that you need is time, or timing, if you will. And in this case, we call it adjustable timing. The ElectroAir system has both. We've accomplished both. The high energy comes from our very high energy coil packs. We put out about 70,000 volts through about 20 degrees of crank rotation. I'll explain why that's important in a minute. Timing. We control timing dynamically through looking at manifold pressure, also calculating dwell time for coils, and being able to optimize the point at which the spark event happens inside of that combustion chamber. Our systems right now on the STC side, we are currently approved as a single Magneto replacement. And what that means is you leave one mag behind, replace the other mag with the electronic ignition system. We're STC'd for almost all 4-cylinder Lycoming and 4-cylinder and 6-cylinder Lycoming and Continental engines. Again, I mentioned before, we're on the approved model list is over 500 aircraft deep. We expect to see on normally aspirated aircraft engines 10 to 15% fuel savings. On a 4-cylinder engine, that means about 1 gallon per hour fuel savings. On a 6-cylinder engine, we're seeing anywhere between 1.5 gallons and 2 gallons per hour fuel savings. If you want to operate very economically, you can even go a little bit deeper. I had a 206 operator up in Alaska that flew the airplane in such a way that he was saving about 2.5 gallons per hour fuel savings. What that meant for him was he didn't have to buy fuel at one of the outstations in Alaska that barge it up in the summertime, and then in the wintertime, your fuel is $16 a gallon. He was able to go up, make the trip, and come back all in one fuel load. Many applications we see increased airspeeds. Now, I have to qualify this. This is not to promise you an increased airspeed, but if you have an airplane like a Comanche, or even a twin Comanche, where it's been designed to be an aerodynamically slippery airplane, if you will, it's not uncommon to see an increase in airspeed depending on how you fly the airplane. You can trade fuel for speed in some cases. If you want to operate the airplane at the original fuel flows that you had, you'll probably go faster. If you want to reduce your fuel consumption and maintain your airspeed that you're used to now, you'll get better fuel economy. It is a function of trade. We also see in almost all applications, and you notice it right away when you install the electronic ignition system, is that the engine itself is running smoother. That's the variable timing in the tuned ignition system that you put on the airplane. All of that contributes to reduced maintenance. Magnetos typically, well, Magnetos now have inspection intervals of every 500 hours. There's nothing on our system that has an inspection interval of 500 hours. We'd like to see it change spark plug wires every 1,000 hours, but if you're flying Part 91, you can look at a lot of that stuff and do it based on condition. Comment, and if Eric Jones is still in the group, he had sent me a chat about wanting to talk about turbocharged applications. We don't expect to see the typical 10 to 15% fuel gains or fuel economy gains in a turbocharged or a turbo normalized system. However, we are now starting to collect data that suggests you'll typically see about 1 gallon per hour fuel savings. The other nice part about it is you'll probably be able to go leaner at higher manifold pressures. In other words, you'll be able to run higher manifold pressures, and if you choose, operate the aircraft lean of peak at those higher manifold pressures. A gentleman, in fact, called today, one of our early adopters with the T210. What he was looking for was better climb performance, and he got it. He was able to lean and manage the fuel mixture in his climb. So there's a variety of applications benefits. The other thing, turbocharged applications, as they get up in altitude, they start to suffer from Magnetos misfiring just because of the nature of the altitude level that they're at. When you get up into the thinner and up at high altitude, the air density obviously decreases. The potential to have an arc or a crossfire inside of the distributor goes up. It's the sole reason, in fact, that Bendix developed the 1200 series Magnetos. Is when they were doing flight testing on the Seneca 3s, they were getting it at high altitudes, and they were noticing a miss, and a very consistent miss from the Bendix Magnetos that they were using. The development of the 1200 series Magneto gave it a bigger distributor block so that the potential for that miss was reduced. Bottom line, there are some very real benefits for turbocharged operators with the ElectroAir Ignition system. As I mentioned, and we have to pay homage to our roots. We started life in the experimental world. I argue that we probably offer the broadest range of kits for experimental aircraft of any ignition system manufacturer out there. We've done every Lycoma and Continental engine configuration you can imagine. We've done every Corvair engine configuration you can imagine. Volkswagens, there's almost an endless number of Volkswagen configurations. Subaru, Jabiru, you name it, we've probably put an ignition system on there. Rotax would be the only exception, and that's only because they come with an electronic ignition system from the factory as it is. We hold or have participated with several people on several world records over the course of time. And in the experimental world, we have nearly 4,000 systems floating around in the marketplace. On the certified end of things, we are closing in on 2,000 systems. Some of our world record holders, Jim Price set the altitude record for a normally aspirated engine, 35,027 feet back in 1996. He, when he got to altitude, he was IMC because the inside of the canopy had completely iced over. And that particular airplane, we were running 4 different electronic ignition systems to help him get there. More recently, we worked with Spencer Suderman, who wanted to set and has set the world record for the largest number of inverted flat spins. When he first approached me, we were just at the beginning stages of doing flight testing on our 6-cylinder ignition system for certification. And he presented me with his ideas. I want to set the world record for inverted flat spins. Well, naturally, my first question was, why? Who in the world wants to set the world record for inverted flat spins? Well, it's like anything else. It's like climbing a mountain. It's because it's there. He's actually broken the record twice. His first record was in a Pitts S2B that he broke it with 81 turns. The only modification of that airplane actually was an ElectroAir system. And then more recently here, he broke it in the airplane that's pictured, which is called the Sunbird. This is a highly modified Pitts S1, single-seat engine or single-seat airplane, obviously, with a Lycoming 540 on the front of the airplane. In order to get to the record of 98 turns, he had to get to 24,500 feet. Well, that's where he started the descent from. Took him about 40 minutes to get there, and 40 minutes to get to 24,500 feet, and about 4 minutes to come down, spinning all the way down. His recovery altitude, his flat deck, in case you're curious, is 2,000 feet above the ground. And he does this over the bombing base at Yuma Air Station, Marine Corps Air Station, Yuma. He's hoping to be able to do it again one more time. He wants to get over 100 turns. And very recently here, the end of 2019, we worked with a gentleman named Bill Harrelson, who in a Lancer 4P broke Max Conrad's round the world flight, westward trip. He did the trip in 5 legs and in 121 hours, which broke Conrad's record by almost 20 hours. In addition, he had actually flight planned for 6 fuel stops on this trip, but because of the fuel savings he was seeing, and he had a Lancer 4P with an IO 550N, and he was able to draw it back 1.1 gallon per hour with our electronic ignition system. He took off one entire fuel stop out of his trip. The real sad part, and I would encourage everybody to go visit his website. Here he breaks this great record in 2019. He wants to do a bunch of air shows in 2020, starting off with Sun and Fun, and we ran into COVID. And it's a real shame because I think the aviation community is, we're not hearing enough about Bill and his record and the work that went into it. And I'm hoping it just doesn't get lost because of COVID-19. Anyway, if you have an opportunity, I would encourage you to go to his website, read up on what he did, and leave him a note. He would enjoy it, I'm sure. One of the other things that I like to brag about is that a couple of years ago, we received the endorsement of EAA, being their official electronic ignition system. And what that means for EAA specifically is that they have gone ahead and installed on all of the aircraft in their fleet that are able to have one of our ignition systems, an ignition system. I think we've got everything on their piston-powered fleet covered with electronic ignitions, except the B-17. And they have already asked me a couple times, when are we going to do something for the B-17? Someday maybe, we'll see. It's be a fun project. That's obviously aluminum overcast is a very neat airplane, and it's iconic, but it's also a really modified airplane, and it's got a lot of cool tricked out stuff to it as well. That as old as it is, it's still a pretty modern flying airplane. Anyway, I'm very, very proud of our affiliation with EAA. Well, while I took a break, and hopefully you were looking at that slide digesting sort of the comparison between a high energy electronic ignition system and a low energy magneto, I want to walk us through just some basic ignition principles, if you will. The goal of any ignition system, whether it be a magneto or an electronic ignition system or a BIC lighter, I really don't care what. The goal of any ignition system in a piston engine is to start the combustion event such that we develop peak pressure somewhere between 10 and 17 degrees after top dead center. Typically in an aircraft engine on a Continental, for example, it's closer to 16 degrees after top dead center. Lycoming should be right in that same area. Reason I bring that up is because this is where some of the critical differences become between what we understand as a magneto ignition system and an electronic ignition system and the expectations that we have today. A magneto uses what we call a distributor to distribute the energy from the coil out to the spark plug. Those you remember, it's a distributor no more than just 4 or 6 points on a block. You have a wiper that takes the energy as the energy comes from the coil, goes through the wiper makes that contact with the point on the distributor block, and off it goes out to the spark plug. Our system, the electronic ignition system, is a distributorless system. It uses high energy coils that are controlled by a microprocessor that are then fired, and that coil energy goes directly to the spark plug. There's no distributor, the energy wasting distributor, I should point out, for the energy to go through. A distributor is much like, I compare it to plumbing, if you will. You're trying to move energy from the coil out to the spark plug without losing any efficiency or without losing any voltage, or losing as little voltage as you possibly can. If we think about plumbing, if we're moving water from point A to point B, any good plumber will tell you that if you put a 90-degree elbow in there, you're going to lose some efficiency of moving that water from point A to point B. A distributor is exactly that elbow when you're trying to move voltage or energy from the coil out to the spark plug. Voltage output at engine start. A magneto is an electromechanical device, so it requires rotation to be spinning, and even with an impulse coupler on it to spin it a little bit faster, the output on an optimal magneto during engine start is about 8,000 volts through about 5 degrees of crank rotation. Our system, because it's driven by battery, is 70,000 volts through 20 degrees of crank rotation. The minute you turn the master switch on, those coils are charged up and they're ready to go. During normal cruise operation, a magneto, again being perfectly optimal, will put out about 12,000 volts through that same 5 degrees of crank rotation. The electronic ignition will put out 70,000 volts again through that 20 degrees of crank rotation. One of the questions that comes up, or one of the questions that I bring up, is do we really know why we have 2 magnetos in the engines in the first place? And the answers that typically come back are, well, of course, it's for safety. We must have 2 ignition systems on board the airplane for safety, redundancy. If we look back and if we dial the clock back in history, that's really not the case. The reason, the argument, the engineering argument for 2 magnetos had to go back into the 1930s to look at it. And you see this explosion of engine technology. These engines are now making manifold pressures that are in excess of 60 inches, 70 inches manifold pressure. You've got, think about the Allison engines on the P40, of course, the Rolls-Royce Merlin engines on the beloved P51 and so forth. Those combustion chambers, if you were to put a single magneto on those combustion chambers, that single magneto did not have enough oomph to completely light off that fuel air mixture and to get the peak pressure point where we want it. Again, remember, everything's foundational, the peak pressure point between 10 and 17 degrees after top dead center. So the engineering solution is, instead of having 1 spark plug, we're going to have 2 split apart. We're going to give half the responsibility for the fuel air mixture to one magneto, half the responsibility to the other magneto, and away we go. So the reason we got 2 mags is actually to solve an engineering problem on high performance airplanes. The reason we have it today, because of regulation and safety, is you have to remember where every regulation starts life. It all starts life as a good intention. And somebody back in the Civil Aeronautics Board at the time, probably post World War II or a little bit before, said that, hey, 2 ignition systems, that's a good idea to have a primary ignition and a backup. That makes sense. Hence, we had the regulation that we had, which resulted in dual ignition systems, or 2 magnetos. In fact, if you look at the original text, the regulation on ignition says you have to have a primary ignition and a backup. The Part 23 rewrite here more recently has changed some of that language a little bit. Spark timing, that's the next one that we talk about. And again, foundationally or fundamentally, have to remember we're wanting to get the peak pressure to occur between 11 and 17 degrees or 10 and 17 degrees after top dead center. Well, when we're down at low altitude or at sea level and we're at takeoff power, we're wide open throttle, high manifold pressures. The timing that we set for the magnetos, 25 degrees before top dead center, which is typical in lycomings, is probably just about right to put that peak pressure point between the 10 and 17 degrees after top dead center. Trouble is we don't stay at sea level for very long at wide open throttle. We climb, we get up into altitude. And as we get up in altitude and as we start pulling the throttle back, the manifold pressure starts to change, it goes down. And in fact, more fundamentally, as we get up into more and more altitude, because of air density, manifold pressure drops down. So if we're at low altitude at high power settings, our fuel air molecules are packed in very close together. They combust or they burn at a certain rate. As we go up in altitude, as we adjust manifold pressure, or as manifold pressure rather adjusts, what happens internally in the cylinder, those fuel air molecules get further and further apart. The length of time it takes for these 2 fuel air molecules to combust and develop peak pressure increases, it goes up. That length of time gets longer compared to when they're real close together. So as we go up in altitude, as manifold pressure drops off, as the fuel air molecules get further and further apart, we want to have a timing. We want to change the timing of the combustion event, or of the spark event rather, so that the combustion event can develop that peak pressure between 10 and 17 degrees after top dead center. And I know I sound like a broken record with that, but I'm trying to make a point. Magnetos, since they're fixed timing, as they go up in altitude, that peak pressure point, if we look at my fist coming up here, compress, 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 spark happens, we come over the top as the pressures are beginning to build up, and we want it to be right about there. As we go up in altitude, if we leave the magneto's time, the magneto is fixed timing, it can't move. It's still going to start here always. That peak pressure point is going to move further down the throw of the piston, and then we're going to experience that as lost work or lost power. That's where you begin to adjust your mixture controls and that sort of thing as you get up in altitude. With the variable timing, we can compensate for that by looking at manifold pressure and by adjusting the timing so that we're bringing that peak pressure point back into the sweet spot of 10 to 17 degrees after top dead center. A little long-winded on this slide, I know, but it's important to understand the fundamentals of ignition systems and really what their goals are within the whole combustion cycle. A couple of last points on this slide: maintenance over TBO. Frankly, the 3 to 4 mags comes from my time selling parts. If I looked at a flight school, they would probably run through, over the course of an engine, 3 or 4 sets of magnetos pretty consistently. Nowadays, we take the magnetos off, we service them, we repair them, we nurse them along, because to buy brand new mags gets to be a little bit expensive. With our system, the only thing we really want to have done over the course of time is the mag timing housing overhauled or replaced at TBO. Fuel savings, well, again, mags aren't going to gain any fuel savings whatsoever. And based on based on what we've been quoting here right along, using $5 a gallon for Avgas, and I use an average of 0.8 of a gallon per hour for a 4-cylinder and 1.75 gallons per hour for a 6-cylinder, you see our projected fuel savings. Now, the lawyer part of me and the stockbroker part of me comes out and says, your individual results will vary, I'm sure. How we do this is through a variety of mechanisms. In particular, we start with very accurate triggering. We use, yeah, that should work. We use a 60- two-tooth trigger wheel, which is keyed to the rotation of the crankshaft. We want that trigger wheel rotating at the same rate as the crankshaft. The two missing teeth, or when I say 60-2, there are two missing teeth on the trigger wheel that we use as an indexing point for the controller. The unit here on the far left is our 4-cylinder mag timing housing. It comes in different flavors depending on whether we're replacing a direct drive magneto or an impulse coupled magneto, that sort of thing. The unit here in the center is our 6-cylinder mag timing housing. Again, that directly replaces the magneto off of one of the pads on the engine. And they come in a variety of flavors depending on whether you're using Lycoming or Continental engines or some of the older Continental E-Series engines and so forth. But everything, all three of those units, everything is based off of the 60- two-tooth trigger wheel. Here we have an installation of an MTH on a Bonanza. Probably should have changed that slide out to a Comanche slide. My fault. Next part of the components are the map sensor and the controller. The controller is the box on the left. That has a very high-speed microprocessor in it, capable of running an ignition system that goes 12,000 RPM. So for our aircraft engines that are cruising around at 2,500 RPM, that microprocessor is barely sweating. The manifold pressure sensor, that's exactly what it is it's picking up manifold pressure from the engine, converting that into a voltage, and sending that signal to the controller, which then does a calculation for ignition timing. Again, with everything being in mind, the goal of being everything, the peak pressure occurring between 10 and 17 degrees after top dead center. Here's some pictures of our coil packs. The coil pack here in the center is our 4-cylinder coil pack. Coil pack here in the far left is our 6-cylinder certified coil pack. And then the coil pack on the far right is our 6-cylinder experimental coil pack. Now, some of you might look at that and say, aha, I figured out his secret. That coil pack on the far right, that must be a General Motors coil pack because I've recognized it from when I worked on cars years ago. Well, almost. It's a coil. They are certainly General Motors coils in the sense that they're in the same package, in the same container. But the coils themselves are high energy coils, higher than what you would get from, say, a Napa store or your local auto parts store. They're performance coils. And we've carried that over into all of our certified stuff as well. You get very, very high energy coils, 70,000 volts through about 20 degrees of crank rotation. Another Continental installation here, you can see the coil pack we like to have installed on the firewall as best as possible. There have been some cases, and I know there have been some cases on Comanches in particular, where there just wasn't the space available, but they were able to take advantage of the engine mount and mount the coil pack on the engine mount. Not my favorite choice, personally. I don't like mounting things on the engine mount at all. But as long as you're using good practices, good common sense, securing it with 8L clamps, and I would even put a note into it later for your annual that you have your inspector just double check the 8L clamps at annual, make sure they're not rotting out or getting loose or that sort of thing. I really can't say too much about it. It's an effective installation. And in fact, that's probably the part that Darrell might have some more observations about it as well, but the coil pack is probably the one item that we spend, or people spend, an awful lot of time thinking about where to install because firewalls get full of a lot of stuff over time. Things to keep in mind about it in terms of selecting location for coil pack installation. We really don't care about temperature on the coil packs. If you have a heat problem on our coil pack, you have an entirely different problem inside the engine compartment. Mainly you have a fire. Take advantage of whatever space you can, or even I've seen stuff where people have put brackets on battery boxes and things like that. Again, you're securing it in such a fashion that it's not going to vibrate. The most important thing is that it's past the engine isolators or the engine mounts themselves, and that very nasty low frequency vibration on the engine. Spark plugs and spark plug wires, big gap on spark plugs, 35 thousandths. Anywhere between 28 and 35 thousandths is an appropriate gap for the spark plugs that are being operated by the electronic ignition system. That's where the high energy benefit comes in, is that we're able to operate a spark plug gap more typical of an automotive engine as opposed to an aircraft engine. Aircraft plugs typically have a spark plug gap of 16 thousandths. So you have this very itty bitty spark trying to light a fuel air mixture off. With our big gap and the long duration spark, we can light almost any fuel air mixture that you put in front of us. Maybe even water. Not 100% sure, but we're probably going to do something to water if you pass it by the spark plug. Our spark plug wires are also different from what you would typically see in a Magneto configuration. A Magneto spark plug wire is referred to as a 7mm solid core wire that has an external braid to it that functions as noise suppression. And you ground the braid at one end, at the Magneto end typically, and then that suppresses the Magneto noise into the spark plug wire. With the high energy ignition system that we have, if we were to use that 7mm wire, what would end up happening over time, and over a very short period of time, I might add, is that you would start to arc, or that energy as it goes down the spark plug wire would start to find its pathway to ground in that shield, and you would start to create a real radio noise problem. So the wire that we use is what they refer to as a spiral core wire. And if you can imagine, the center core of it is just a non-conductive center. It has a stainless steel, very, very thin stainless steel wire wrapped around it, which builds a resistance profile. Our wire in particular has a resistance of 5,700 ohms per foot, and that acts to suppress the noise coming from the high energy ignition system. This type of wire was first used actually in what I would call the most common all-composite car in the auto industry that was produced. And if you're guessing, the all-composite car in the auto industry was the Corvette. The Corvette, when they began introducing high-energy ignition systems onto the platform, they ran into a very large radio noise problem, and in fact found a wire company, a spark plug wire made in Australia, and had it brought here and initially used that wire for noise suppression over the course of time. Same is true with high energy ignition systems for aircraft. We use the 5,700 ohm wire has probably solved the majority of our radio noise issues that we run into today. And it can help, actually, I think it can help cover up some of the sins that you run into with old aircraft, either poor connections or poor grounds, that sort of thing. When we first STC'd the ignition system, we used to rely on the rotary key switch as a way of controlling both the electronic ignition and the Magneto. There would be a separate toggle switch for power, of course, but we would typically use the rotary key switch to control both the ignition and the Magneto. And we've discovered just how poor of a job that rotary key switch, or what a poor switch design that rotary key switch really is, and how much maintenance it needs. A rotary key switch is a key switch that is normally open. So when you're operating in both, the two switches on the inside are open. When you select left mag, for example, which has anybody ever wondered why the left mag position is always in the right-hand spot? I've asked that question. I've never really gotten a good answer from anybody about that. But anyway, if you select left mag, internally in that key switch, the switch path for the right mag closes, you ground it out, and you then look at the left magneto operating the engine. Go back to both, let the engine recover, rotate it over to the right-hand position, and you're grounding out the left-hand magneto. With the electronic ignition, if, for example, the electronic was in the right-hand position and you selected left mag, what you would ground out would be the trigger mechanism or the signal coming from the trigger mechanism. That would effectively shut down the electronic ignition, which is great. We'd see our drops and everything else. But if instead of going to both, we rotated over to right because we were in a hurry, well, the switch path would open up. And now what we've done is we've grounded out the signal going to the controller. The controller needs to see that signal again and go a revolution or two before it'll begin firing again. That creates a delay that you perceive in the flight deck. And in some cases, if the switch itself, the rotary switch, is not been taken care of or not been maintained very well and lost some of its snappiness, you could have a backfire, a little extra tailpipe, a little extra fuel going down the tailpipe, causing a backfire. Well, we developed the ignition switch panel to eliminate the rotary key switch, one. I think it's a better way to operate the aircraft because it slows you, the operator, down a little bit so that you're looking at both the RPM drops of either ignition and you're looking at the delta between the RPM drops of both ignition systems. And let's face it, it also saves us the embarrassment of getting strapped into the airplane and realizing we left the keys in our pocket. That's happened to me more times than I care to count. Pete made a comment during one of the discussion points that the disappointing part, though, is you lose the security of the key switch. And we also, by the way, the switch panels were received so well that we went ahead and did them for Magneto to Magneto configurations as well. The security of your airplane with regards to a key switch or even the door lock is, you have to be realistic about it, is somewhat limited. It's not an exaggeration to say that I probably have all 6 keys in my toolbox that'll start any Cessna around. That's very, very typical of anybody that's been in maintenance for any length of time. And same is true with the Pipers and the Beechcraft line as well. They were not very sophisticated devices. For security, your best bet, I think, to use a throttle lock or some kind of a prop lock even would be better.
No prop lock.
Sorry, no prop lock. I stand corrected. A throttle lock on that. For those of you that don't know Darrell, Darrell spent a few years within the prop industry. I'm not sure how many.
35.
35 years within the prop business. And if you have questions, I do promise you, if you have questions about propellers of any kind, Darrell's a good go-to guy for that, as well as electronic ignitions. Getting close to wrapping up, a couple of the final things here. We are very close to releasing a kit that will replace the single drive Bendix dual Magneto. Now, for all of you in the Comanche world, that's not really important because thank God you don't use this at Magneto. This unit is frankly, is a very dangerous unit if you look at its history and all of the AD notes that are associated with it. But we have come up with a kit, and we've upgraded our software so that we can run a dual ignition system to replace the Bendix dual Magneto. So it'll have the one trigger mechanism off of the mag drive where the dual Magneto is at. It'll also use a crank trigger wheel kit, which some of you I know some Comanches have used this as well in the 6-cylinder applications. And it completely separates both ignitions. You'll have dual independent coil packs, dual independent controllers, truly, finally a true dual ignition system that'll never have any kind of a common failure mode. I'm hoping that will receive approval for this unit by the end of September, somewhere that time frame. One last slide here, just some real world gains. Again, one of the, he's probably had to step off because he said he was going to have to leave early. Comanche operator out of South Africa, Stefan, has put the system on his turbo normalized 260 and saw some very significant fuel saving gains, 10 gallons an hour at 140 knots. Those of you who've got turbocharged or turbo normalized applications would know better what those numbers should be. But he was very impressed with the fuel flow that he was able to get and still maintain 140 knots. Again, we talk about airframes that if they're designed with aerodynamics in mind, and the Comanche and the Bonanza airframes, I would argue both, had been designed that way. They are slippier airframes with a better ignition system. They should go faster. I can't promise that to you, but that's the typical data that we're seeing, is both a little bit of fuel savings and some more airspeed pickup. And then finally, of course, the 180 down there, which is not necessarily designed to be super aerodynamically slippery. It's designed to be a truck. This gentleman was very impressed. His takeoff roll was 1,000 feet on a 6,500 foot day, and 200 pounds just under max takeoff weight. Pretty good stuff. And on the Cessnas, again, on the 6-cylinder engines, consistently see 1.5 gallons, 2 gallons per hour fuel savings.
Did you know sleep equipment manufacturers recommend daily cleaning? That's why I use Soap. It's the perfect complement to my daily routine.
I think somebody's got a microphone on by mistake. But Pete, again, everybody, I want to just thank you again for letting us take some of your time up this evening. The ElectroAir system, as CJ said, Darrell has got some special packages put together. If you, this final slide here, you can contact me directly and I'll get you in touch with Darrell. Or if you take your cell phone, if you've got a smartphone with a camera, and just put that over the QR code, that'll link you to, that'll take you to a website link and a form that you can fill out, giving your airplane information. And Darrell will respond to you with a couple of different options for ignition systems. Then, of course, obviously, if you want to ask questions, further questions too, about how the system performs, that sort of thing, by all means. So again, thank you very much, Pete. I don't know, Pete or CJ, I don't know if we've accumulated some questions.
Yeah,
we have indeed.
Looking at the chat,
And,
you want to unshare, and we can get back to seeing some people. There we go.
So, yep. Well, thank you very much, you guys. I'm just going to jump right in from Wayne Smith. What's the range of timing advance? You touched on this, but I'm just going through these one by one. And Matthew jumped in and said the installation manual, page 5, has the vacuum advance curve. Looks like it maxes about 15 degrees, but Mike or Darrell, you want to, and he posted a link, by the way, everybody. Do you want to go ahead and respond to that?
Yeah, 15 degrees is the max advance. And you're only going to see that at really low manifold pressures. You can do the math. The timing curve is no great secret. The magic number here being 24 inches of manifold pressure. At 24 inches, we're going to fire at the same time as the Magneto. Obviously much longer, much brighter, much hotter, more powerful. But when you fall below that 24-inch magic number, that's when the timing curve is going to kick in. So for every inch below 24, it's going to be 2 degrees of advance. So in order to get down to that 15, you're going to have to be 6.5 inches below 24 inches. Obviously, puts it at what quick math, 17.5 inches of manifold pressure. You're going to be maxed out on the timing curve. And interestingly enough, that's one of the things that I see a lot, because I pay attention to the different blogs and forums. A lot of guys complain that we don't have a gauge that we can put in your panel to show you what your timing advance is at any particular moment. Really? Do we really need that? There's enough cockpit noise without that. That's going to have no bearing on how you're flying the airplane. However, Mike and I had a conversation earlier this very week. I said, you know what? Hey, one more bell and whistle, and if that's what people want, let's come up with a gauge that they can stick in their panel, and they can watch that timing advance. You guys can chime in if you want to on whether or not you really want something like that. Something else is going to add more cost to the system, but it is something that we can do.
Maybe a digital output to a digital engine monitor would be interesting. I don't know if I actually need a separate gauge though.
Oh, Mike, you want to chime in on that?
In our experimental systems, we do have a digital output. It's actually just a simple voltage. And I don't think we put a wire in the harness for it, but we do have the output for it from the certified system as well. And yes, the best way to do it would be to, if you need to have it, would be to use an aux input on one of the engine monitor systems. Most of them have them, I think. You've got to range the gauge from 0 to 0.5 volts. And it's just the voltage displays directly. So in other words, if you've got a voltage output from our system of say 0.25 volts, that translates to an ignition timing of 25 degrees before top dead center. If it's 0.29 volts, then it's 29 degrees before top dead center, so on. One of my apprehension with it has always been is it doesn't give it's a handy tool for troubleshooting. It doesn't give the pilot really anything that he can act upon, versus if you're monitoring CHTs, you know, and you see your CHTs increase to a certain point, well, you can act upon that by increasing the mixture, pushing the nose over, slowing the engine down, doing a variety of things that way.
Yeah.
Timing advance just doesn't give you that. It doesn't give you information that you can act upon. And in troubleshooting it, I will tell you early on when we owned the company, Jeff, actually the original owner of the company, put out a timing gauge. And one of the things that we would get back is that somebody would be taxiing around at low RPM or near idle, and their ignition timing is up to 38 degrees before top dead center. and oh my gosh, you know, the sky is falling kind of a thing. At the low RPM, at the low manifold pressure, that's exactly where you want that timing to be, is way out to 37, 38 degrees before top dead center on a 4-cylinder Lycom. Because they would come at me and say, oh, the sky is falling, and I would respond back, okay, well, how does the engine sound? Oh my gosh, it's never sounded so smooth in its life. Well, again, the 38 degrees before top dead center, what that's doing is giving that combustion mixture, that fuel air charge, enough time to combust and holding that peak pressure point to that sweet spot of 10 to 17 degrees after top dead center. In a Magneto, in that same circumstance, the peak pressure point's probably occurring around 25 to 30 degrees after top dead center, which is where you get the real roughness, the ka-thunk, 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 that sort of thing. So,
hey, Mike, one of the things during your presentation that you did a pretty good job of hitting home on is that sweet spot for peak pressure. One of the things that I wanted to bring up about that, with the fixed timing of magnetos, and especially as we go up in altitude, and we're having that peak pressure occur later and later in the throw of the piston, the other important thing that's going to occur, and we see this a lot, especially in the Bonanza world, and it can be true with you guys too. Some of you guys fly pretty high. You end up with a situation where you still have fuel in the plasma or the burning state as the exhaust valve opens. And that's not a good thing. And that's actually going to shorten the life of an exhaust valve. If we only have hot gases going across that exhaust valve, that's not a terrible thing. Burning fuel going across that exhaust valve is a very bad thing. The more of that we can eliminate, and you'll see it when you put the system on your airplane. If you guys already have it and you have engine monitors, you've already seen it. We do expect a slight increase in CHT. And that's just a function of doing more work inside the cylinder, inside the chamber. But conversely, we're going to see a pretty dramatic drop in EGT. And EGTs, in my opinion, don't really get talked about enough. They are important. For your turbocharged guys, that equates to lower TITs. which is also an important number. Just wanted to interject that in there while I was thinking about it, Mike.
No, good point.
And I think a lot of interest in that. Thanks, Darrell, for adding that in. From iPad 71, a link to the party. Is this compatible with a carbureted engine? And while you're answering that, if you can talk about running lean of peak or not in the carbureted engine with electronic ignition, that would be great as well. iPad 71, do you want to add anything to that? Go ahead, Mike and Darrell.
Well, we'll just launch in. The electronic ignition system is absolutely compatible with a carbureted engine. In fact, because of the high energy coils, what you're able to do is with a carbureted engine, you're able to lean better than what you had before. And the problem with the carbureted engine is that the atomization of the fuel and air, because it's tracking from that one carburetor out to the cylinders, it becomes very variable at each individual cylinder, which makes it very hard to run lean of peak. The electronic ignition, because of the high energy coils and the high energy spark, will run leaner than a traditional Magneto will run, or will light off a much leaner fuel air mixture, I should say, than a Magneto will. And you're able to lean better. So the fuel savings are there for a carbureted engine just as they are there for a fuel injected engine.
Thanks very much. Any other comments about, can you actually run lean of peak in a carbureted engine? Which we normally avoid doing.
Yeah, right. No, we've had a number of people say that they were running lean of peak in a carbureted engine. And even when you're running in an injected engine, you're able to typically run, I call it lean of peak, if you will. What's happening, really, we don't, well, and CJ used to talk about lean procedures, lean of peak procedures. My recommendation from the factory would be to lean the aircraft engine in accordance with the aircraft engine book. There is a provision for lean of peak in all aircraft engine manuals. It's right there. Take it to 50 degrees lean of peak. With the electronic ignition, and what you find with the electronic ignition is what happens because of the high energy ignition system, the peak EGT point actually shifts. And it shifts from what you would see from the flight deck, you would see it as a further pull of the mixture control, where you would pull the mixture out further than you would normally to get to that peak EGT point. And then of course you adjust whichever direction you want to go, whether you want to go rich peak, lean peak, that's up to you. But the fact of the matter is that with the electronic ignition and its ability to fire, because of the high energy coils and the variable timing, its ability to fire that leaner fuel air mixture, the peak EGT is actually going to occur later than what it would on a conventional 2 Magneto setup. So you end up being what I call, again, lean of peak, if you will. I would still follow the same procedures that you do and follow procedures of the engine manufacturers. Funny anecdotal story while I'm thinking about it, comes out of a Bonanza. One of the American Bonanza Society tech guys got it on his Bonanza, Bob Ripley, and he and his wife were flying from Atlanta down to Florida. He got everything trimmed up, and he just wanted to see how lean he could go with on his airplane with the electronic ignition. Now it's also got gamma injectors as well, which I see a text on there about the gamma injectors. System works great with gamma injectors. I don't think gamma injectors are as popular in the Lycoming engines as they are in the Continental engines, but there's no conflict with running our system with gamma injectors. Anyways, Bob's flying along 8,500 feet. He starts dialing out the mixture just to see where it would go. And he keeps going and going and going. All of a sudden, he's to the mixture idle cutoff. And the engine just goes, and everything gets real quiet. And he says, well, I'll be damned. He dials the mixture back in. Of course, the engine fires right back up, and away he goes. His wife's looking at him, glaring at him, going, what in the, don't ever do that again. The point of the story is you can go pretty lean with the electronic ignition system.
Well, Bob sure tells that story a lot better than you do, Mike. He had the whole room on.
That is great.
I'm going to blame this is on Zoom, not necessarily me.
Good call.
Yeah. One from, yep. So one from Matt, you knew this was coming, which is what are the advantages of the ElectroAir's electronic ignition system over SureFly's variable timing mag product?
Mike, you want that one, or you want me to take that one? I was going to bring it up anyway.
Go ahead, Darrell. Tear it up.
It's pretty simple. Science, and in particular physics, pretty tough thing to overcome. And one of the things that I think Mike has done a really great job of explaining to everyone, the ElectroAir system is a high energy ignition system. And Mike, unfortunately, can't take claim to fame that he developed that. It was actually the engineers in Detroit in the auto industry that came up with high energy ignition. The reason they came up with it is because they had to. When we took lead out of auto gas, what did it do to the octane level? It dramatically dropped it. Lead is an additive that's used to increase octane. And if you study it, which I've done a little bit of it here recently, it was a big deal back in World War II trying to figure out just how much lead to put in the fuel for these big radial engines. It's a pretty interesting read if you can find. I wish I'd had the links ready for you to go look at it. But anyway, it was the guys in Detroit that figured it out. They had to come up with a way to keep these big bore V8 engines running correctly on a lower octane fuel. The way that ElectroAir does it is, like Mike explained, is with a large inductive coil. That inductive coil in the 4-cylinder side of things takes less than an amp and turns it into 70,000 volts. On the 6-cylinder side, it's a little over an amp. Again, turns it into 70,000 volts. Voltage is very, very important when it comes to having the ability to jump a much larger spark plug gap, and more importantly, with a lot of energy so that it actually gets that fuel burning. And that's why those of you out there that already have the ElectroAir system, you've already seen when you do your ignition check and you turn off your Magneto, nothing happens. It basically, and then the manual will tell you, we don't want to see any more than a 30 RPM drop. The more typical is 10 or less. I have this system on 3 of my lease back airplanes. I don't have any drop. Part of that's because I'm anal and I've dialed the NTHs in to where there is no drop. But coming back to that big inductive coil, we can't cram that thing into something the size of a Magneto. You just can't do it. And interestingly enough, if you look at SureFly's website, which we obviously have, they call themselves an electronic mag replacement. And that's really all they are. They're a replacement for a Magneto with no additional voltage. Yes, they've got variable timing. They've got it approved on some airplanes to use it. You have a restriction. You have to have an engine monitor to use it. You also have a fuel restriction on their STC. You have to use 100 low lead. ElectroAir doesn't have either one of those requirements. Really what it comes down to, like somebody's got an open mic, really what it comes down to is what you expect out of an ignition system. If you just want something to replace your Magneto so that you've got one last Magneto to maintain and you're not expecting a lot of performance gains or any fuel savings, then by all means, please buy the SureFly system. If you're serious about performance and you're serious about seeing some real life gains in not only power, climb, speed, and real fuel savings, I've experienced this myself in my own airplanes. We lease these airplanes wet, and we're saving 2 gallons an hour on our 172s. And well, about the same thing on the Archer. We haven't had the Archer in the air long enough to have enough data, but 2 gallons an hour when you're leasing an airplane wet, these airplanes fly 75 to 125 hours a month. That's a huge savings. It's big time. So the two systems, in all honesty, aren't comparable. The SureFly unit really isn't a system. It's just one unit that pops into place. Is it easier to install? Absolutely. But one thing you got to keep in mind about the SureFly system, it's a throwaway unit. The ElectroAir unit Once it's installed on your airplane, it's there for the duration of the airplane. Again, like Mike said, spark plug wires at 1,000 hours, really on condition. The mag timing housing, again, 91 operations, on condition, but the ICA tells you to replace it at engine overhaul or 2,000 hours, whichever, well, no, not whichever occurs first. And I tell everybody it's 2,000 hours. And that's the only thing you got to do to the system. Spark plug maintenance is still the same, but the bottom line to the whole argument, to the whole conversation, is we are a performance system, and that's what we're all about. Hopefully that answers it.
Couldn't have said it better myself.
We're happy to have both because they solve different problems. But oh, sorry, go ahead.
I said I had a really good teacher.
Yeah. Well, speaking to that, and there's a reason I flipped Matt's and Daniel's, but Daniel, Sir mentioned to everybody, it's interesting you talk about the pause when going from one mag to the electronic ignition when doing a mag check. He says, I have a Surefly, sorry, and it does the same thing, especially gets your attention when doing an airborne mag check. Is there a reason I can't use your ignition switch setup on my Surefly? I like the thought of that.
Oh, pick me, please.
Go for it.
Pick me. Yes, you can absolutely use the ElectroAir switch panel. It comes in two different flavors. The EA 13000 is designed to be used exclusively with the ElectroAir system. It is labeled EIS and MAG. The EA 15000 is labeled left and right. And that can be, in the way that the certification is written for the EA 15000, it is to be used with two Magnetos. The fact that Surefly calls themselves a Magneto makes it legal. I sell these switches about as fast as Mike can produce them, the 15,000s. And it's a combination of people that are installing the Surefly. Again, hey, we live in a capitalistic society. God love it. Glad somebody came along to put a boot in our ass and make us even better than we were before. But the switch works great with the Surefly system. And the reason that we like it is because now our name is, the ElectroAir name is right there on the panel. And for those that want to know the price, that switch retails for $270. If you call me and say you need the switch panel because you put a Surefly unit in there, I'll give you a discount and only charge you $540 for the switch.
And actually, speaking of switches, we'll be posting the Comanche Group Buy Special information later on tonight on Delphi and the Facebook group and sending it to the mailing list. But do you want to say, Darrell, or do you want me to say?
I'm sorry, say that again, CJ.
Regarding that switch, I just was saying to everybody that we were very fortunate. Earlier this year, we negotiated a group buy special. There was a little delay in announcing it with the electronic ignition with ElectroAir. And actually, Surefly came to the party as well. We were very, very pleased that they would also do this for the Comanche type. We had a little delay in posting it, and so but that was a good thing for us actually, because one new cool thing happened. So that switch that we're all just talking about right now, Darrell, do you want to say what you're going to be doing special for the Comanches and nobody else, or do you want me to say it?
I'll do it. I'll be happy to.
Yeah, please.
CJ and I will say that we thank CJ a great deal. She has meant a lot to us, getting us involved with all you Comanche guys. We've done a couple of group buys through CJ. It's been fun. Really met a lot of great people. It's been a good time. Currently, we are running, or I'm running an Oshkosh show special on these kits. And I guess the biggest thing I want to say here to you guys who already have the system, yes, it is cheaper now than it was probably when you bought it. And the analogy that I use, I can remember back in the 70s when my grandparents bought one of the first microwave ovens. That thing was about the size of a refrigerator and weighed about as much as a refrigerator. And I couldn't believe they spent $800 on a microwave oven. That same technology today, which is 10 times stronger, pick them up at Walmart for $50. Not a lot of difference with technology like the ElectroAir system. Between a lot of hard work on ElectroAir's part, a lot of hard work on my part, we've been able to whittle this price down. You may have noticed that you don't see any of my advertisements anymore. We have cut that expense out. Instead of me having all these systems shipped down here to me and adding that extra cost, I purchased my inventory from Mike. He's got a separate room up there that he stores it in for me, and we drop ship directly out of the factory. We've done everything we can to get as much cost out of this as possible to make it more palatable for you guys to afford. I'm an aircraft owner too. I understand there's only so much money to go around. Getting back to the switch panel, for you guys and you guys only, the price of the system, it is our show, Oshkosh show special price. I've also got discounts on both our massive electrode plugs and our fine wire plugs, which are awesome plugs that are manufactured by our great friends at Tempest. We are going to give you the switch panel with the purchase of the system.
We are thrilled. Thank you so much. And part of what's cool is, you know,
Don't tell your Bonanza buddy next door to you that we gave you a switch panel.
I got a Barron guy texting me right now. I'm being quiet. Thank you so much for doing that. I'm serious. I'm not joking. So I just wanted to keep back to the great questions. Laurie Sutliff's got a great one. Is there a provision to keep the ignition running if there's a power failure, like an aux battery? And in addition to that, his second question is, how much power does the ignition system draw?
Let's deal with the second question first. The power draw, it depends on whether you're a 4-cylinder or a 6-cylinder application. The power draw on the 4-cylinder application is about 3/4 of an amp. So 0.75 amps. On the 6-cylinder application, the power draw is 1.25 amps. So 1.25 amps. So when you're doing your budgeting or your load shedding, for example, if you have an alternator failure and you follow your procedure to load shed, that's what you need to consider as far as adding it up in a device. Is there a provision to keep the electronic ignition running should there be a massive electrical failure? In other words, you lose the whole bit? No. And that's the reason why at the moment it's certified as a single magneto replacement, is that if you lost everything, which doesn't happen very often, but it does happen. So if you lost your voltage regulator, your battery, and your alternator, and you had a completely dead electrical system, you would still be running on the magneto alone. The provision we're making for, I mentioned about the the Bendix dual magneto and running dual electronic ignition systems. The provision we're making for there is that you have to have some sort of a backup power supply system. What I suggested to the FAA was a backup power supply system that would run the MEL plus the electronic ignition systems. They haven't come back to me yet with what that's actually going to be, but I think that answers the question.
Yeah. So if there is a power failure, obviously we're going to continue to run on our existing mag. Yeah.
Correct.
Yep.
Yep.
By the way, I have experienced this very scenario. Back in January, I was flying with a customer, gentleman from up in the panhandle of Texas that had the system installed on a Cessna 180. Probably the most awesome 180 I've ever seen. He had probably a little over $300,000 invested in this 180. Had a 550 conversion on it, the biggest Macaulay propeller he could put on it. A beautiful wood inlay panel with just about every gadget that you can cram in there. Had some issues with the installation. We got them corrected, and unfortunately corrected a lot of other things that had been missed by his mechanic, like the exhaust was about to fall off. He had a weird noise that was occurring when he only had the ElectroAir system on. Turned out with the ElectroAir system on, the engine producing a little bit more power, it was pushing the exhaust into the cowling, and that was the noise. Got all that fixed. Got all this work done, and he said, "Hey, let's go fly. I want to check this thing out at 11.5." I said, "Let's go." We were climbing out of KLVJ, which is Pearland Regional, just south of Hobby Airport. We got to 9,000 feet, and I guess I should predicate this. I've been in aviation for 41 years, and I'm not a pilot, and I own airplanes. I've always been on the wrench side of aviation, and that's probably where I belong. I'm a little crazy. But, at 9,000,
a little crazy?
Yeah. At 9,000 feet, I hear this, huh, which always gets my attention when a pilot says, huh. I looked over and old Red, Red's about 83 years old. He's tapping on the amp gauge, which I look over and while he's tapping on it, it's digital. It's not like it's going to change anything. And it's clicking off backwards like a countdown for a rocket launch. And I said, Red, I think we've lost the alternator. And he said, yeah, I think you're right. And I said, what do you say we go ahead and level off and figure out what we're going to do here? So we did. And he cycled the alternator a couple of times, didn't come back to life. I said, well, we were directly above a very large runway at Galveston Island, an Air Force base. We're about 15 miles from where we took off from. Got Ellington Airfield. We got multiple choices here. Or you can land on the road by my house and I'll just walk home. So we started. And of course, in Class B in the Houston area, you got to get down quick. And he wasn't really descending quick enough. And I had to remind him, I said, you need to point this thing down, which he did. And as we're descending, all these gadgets and all the fancy stuff he had on his panel started flashing red lights and power, and they were clicking off, turning off. And I said, you need to start shedding turning some of that stuff off. We don't need it. Come to find out, and I'll explain later in the story, he does need it. He asked me, he said, should we turn off your ignition system? Called it my ignition system. I said, you know, I really like the idea of having 2 ignition systems, but let's leave it on. It's a pretty low amp draw. Let's leave it on. Long story short, we got down to an engine running on the mag and the ElectroAir and one radio. We lost everything else. And he's getting a little antsy as we're getting closer to Pearland. And he says, you're going to have to help me watch for traffic. I said, Red, I'm already on it. Way ahead of you. So you got two guys doing touch and goes at Pearland. One just took off. He's turning back towards base. I said, make your announcement that we're coming in and follow him in, and we'll be fine, which we did. Followed him in. We landed safely and pulled up to the hangar, and he shut the engine off and tried to start it again, completely dead, wouldn't even turn over. I get out of the airplane and I'm looking for my business partner that owns the shop there. I said, hey, we got electrical failure. What are we gonna do to fix this? Red steps out of the airplane cussing like a sailor, and I looked over and I said, Red, what's the matter? And he said, well, I figured out why we dropped electricity so fast. I said, why is that? I left my landing lights on the whole time.
Oh.
The moral of the story is, yes, we had a total, and I had him shed all of his fancy gadgets. We had a radio, we had a compass, and we safely made it back home. We actually could have turned off the ElectroAir system and flown for as long as he had fuel. And that's kind of the beauty of this system. And actually the FAA, when they did their safety assessment of the ElectroAir system when used with the Magneto, which they have to do during the certification process, it was their conclusion, not Mike's conclusion, that by using 2 dissimilar ignition systems, the safety factor increased on a magnitude of 2 or an order of 2. And what that really calculates to is 200,000 times safer running an ElectroAir system on one side and a traditional Magneto on the other side. That's pretty significant. And I know one of the things, CJ, you and I have been talking about the past couple of days is, and I applaud you Comanche drivers, by the way, paying so much attention to safety and taking care of these airplanes. They're older airplanes, maintaining them. It was interesting when you told me that the majority of these accidents in your community are all fuel related and people not managing their fuel properly. Well, the more things that we take out of the equation that you guys have to worry about, the better you're able to handle flying your airplane. I call it cockpit noise. And that's one of the reasons I'm not a big fan of adding one more gauge to the panel to show you your timing advance. Even not being a pilot, I've literally flown hundreds of hours with multiple pilots and multiple different types of airplanes. Some of them I probably shouldn't have been in. Not a big fan of experimental airplanes. but I've learned a lot about what it takes to take care of flying these airplanes. And the less you guys have to worry about, the better off you are. Sorry, I kind of got off on a tangent there, but that's my story, and I'm sticking to it.
Interesting story. Thanks, Darrell. From Robert, does the electronic mag fire once or twice in a cycle?
It actually,
Well, I'm not quite.
Go ahead, Mike.
I was just going to say, I'm not sure what you mean by cycle. Our system is referred to as a waste spark system. So when you're firing, the way the coils are set up, when you're firing on the one cylinder that's in compression, you're firing on the corresponding cylinder that's in exhaust. The reason that was done is designed that way intentionally was to complete the circuit of the coil. It has the effect of getting a cleaning spark, if you will, on the spark plug that's in the exhaust phase of the engine rotation. You draw, the exhaust valves are open, there's no pressure inside of the cylinder. You put a high energy spark across that spark plug. If there's any contaminants built up from the previous compression and power stroke, they're burnt off and out the tailpipe. You can see that when you do your spark plug inspections, if you do them every 50 hours or 100 hours, that sort of thing. We expect that the plugs will be cleaner than what they would be on just Magneto plugs alone.
And
Very cool.
Matthew, if you're still out there, that's one of the reasons we need to get you and Ron Cooper talking on your particular airplane and find out why we're getting build up on your spark plugs.
Yeah. Wayne Smith had a really key question about, is there a self-test, like if the manifold pressure sensor failed, how would you know? And Mike wrote back an answer, but Mike, do you want to go ahead and just talk? Because some people can't see that chat screen.
Sure. The question was, is there a self-test, for example, on the manifold pressure sensor? How do you know the manifold pressure sensor is working? Bottom line, that's the real question. And it's the ignition check. When you bring the engine up to 1700, 1800 RPM, you shut off the electronic ignition, for example, you will see your typical RPM drop for single magneto operation, probably even a little bit more than what you had before. So it's not uncommon to see an RPM drop on a Lycoming get to be about 75 to 100 RPM, maybe even 120 RPM. Go back to both, let the engine recover, shut off the magneto, and what we expect is that you're going to see a very little RPM drop or a slight RPM drop. On a four-cylinder Lycoming, it's very typical to not get any drop whatsoever. And on a six-cylinder engine, a drop of 10 to 20 RPM is very typical. The flight manual supplement says it limits you to a drop of no more, I think, than 35 to 40 RPM. But we see typically in practice, only 10 to 20 RPM drop. The reason for the limit of no more than 35 to 40 RPM, if you get much beyond that, then there's really something probably wrong. The ignition is not timed correctly. We might have, if you've got a rough running engine, you might have a spark plug wire that's not been fabbed correctly down inside of the spark plug well, that sort of thing.
Cool. Just a real quick aside before I go on to some of the other, these questions are amazing. I'm so happy to be reading them because I'm learning so much. But I do want to just say, I just noticed that we have somebody with us tonight who I just want to acknowledge. Virtually every great Comanche instructor that we have that's teaching today learned from Larry Larkin. And I did a long-term analysis of Comanche accident statistics in the NTSB databases, and Larry Larkin is on with us tonight. And Larry, it looks from the statistics like your initiation of teaching us Comanche drivers was followed by a steady decline in the pilot error accidents. And so I just wanted to say hello and welcome, and to say how much we all appreciate everything that you've done for us. So thank you for being here. And to just everybody, if you've learned from a great Comanche instructor, your great Comanche instructor almost certainly learned from Larry. I don't want to embarrass you, Larry, but thanks for being here. if you if you if you've got mic control and you want to say hello, feel free. If not, I don't want to put you on the spot, but that's all. And so the next question we had was again from Larry Sutliff. How low of a voltage will the system continue to operate?
The low voltage minimum on our system is 8 volts. But as I mentioned in my my reply back to Larry, that's on a bench. We have to remember that once we get systems into the airplane, just from wire harnesses and wiring up an airplane, the actual low voltage number might be probably closer to 9 volts.
Beautiful. Let's see. By the way, I happen to know we've got a Comanche driver who flew recently a 180 over the Rockies with electronic ignition. That'd be Robert Key there. Do you want to just quickly talk about your manifold pressure readings going over the Rockies with electronic ignition in the airplane?
Yes, one of the things that this is Robert Klein. On the way back from the Comanche convention, flew over the Rockies at 14,000 feet. I have the power setting table in front of me right now, and it says at 55% power to pull 16.5 inches. I think we were pulling closer to 18 or 19. I know we were at least an inch, if not an inch and a half up. Now I tend to like to go a little less than 2,400, 2,300, and I know there's a relationship there, but not only was it at 14,000, but more recently at 7,000. It says 75% power is 22.2 inches, and I have plenty of throttle left. So it's absolutely clear to me that I'm producing much more power than what a brand new engine does above 5,000 feet, and it's even more apparent above 8,000 feet. So it works well, and the engine runs really smooth, and I'm glad to have it.
Remind me again where I'm supposed to send that check to?
Well, I was very fortunate that the previous owner had it installed a number of years ago, so he's had the advantage of it. But one of the things is that the fuel flow on climb out, I look over and I have to keep dialing back the mixture to something like, even on climb out, 11 or 12 gallons an hour is too high. It's got to come back to like 10. And when I do that, I can see the increase in the rate of climb, and it's even more dramatic than 100 feet per minute above 5,000 feet.
Wow.
Beautiful.
Thank you, Robert.
Well, I think what I'm hearing from a lot of people is that because the laminar flow wing in the Comanche does so well at altitude, and I'm guessing the Moonies have the same experience, but our carbureted engines typically, these changes, because so many of us were built before 62. In fact, more of the Comanches were built, the singles were built before 62 than after. 63, I think, was the cutoff. Something like 60% were built by 63 of the singles. So marrying a system like this to our wings, which just love to be up high, is kind of, when you look at it now, it's obvious, and so electronic ignition, both of them are great, but this one in particular seems to be well suited to our aircraft. And we're again, we're thrilled to have both choices, and I know that's not so great for ElectroAir, but it's good for us. Back to the questions. What is this from Matt? And this is one that I've heard a lot and seen chatted a lot. What does a typical Comanche installation cost? And you're going to say there is no typical Comanche installation, but we're still going to ask you to answer.
Well, actually, there is no typical installation. Period. And I'm involved in a lot of installations because it's a big part of what I do. I call myself an old school distributor. I don't just sit behind a computer all day and take orders and tell Mike to ship this stuff out. I actually spend most of my time on the phone dealing with guys that haven't installed the system before, or dealing with new customers that are trying to understand how the system is going to benefit them. And occasionally we deal with some troubleshooting problems. I will say on our troubleshooting side of things, probably better than 90% of the time, it's actually something in the engine, or it's an installation issue. One of the things that the ElectroAir system is really good at finding problems with the engine Magnetos just didn't expose. It's the old adage, it's the next weakest link. One of the most common things we see is induction leaks. That's very common. Induction leaks with Magnetos, probably not as big a deal, but when you put a high performance, a high energy ignition system into that corrupted fuel air mixture, it's going to show up. Damn, I kind of went off on a tangent, and I need to get back to the original question. Remind me again what the question was, CJ?
Installation times.
Oh, yeah. I was trying to avoid it. Obviously, this system, and again, I emphasize the fact that it is a system. We've got two components, mainly the controller and the map sensor, that have computers and microprocessors inside them. We want those inside the airplane, and there's a very good reason for that. One thing that electronics don't like, or probably the main thing that electronics don't like, is heat. They also don't like vibration. So the smart place to put those components is inside the airplane. On the warm side of the firewall, you've got your mag timing housing or crankshaft trigger wheel, and of course your inductive coil pack. So we've got to find places for all these components. Obviously the mag timing housing, that's easy. It's going to replace one of the Magnetos. You're going to set number one cylinder top dead center. You've got a pinning location on the mag timing housing, which zeroes it. You plug it in, lock it down with your two clips, and that part of it's done. The installation can be done, as I've been told by an installer, on a Piper Arrow in 6 hours. Now, when I heard that, I thought, good Lord, that's probably not a very clean, pretty installation. What really takes the time is running your wire harness nice and neatly, proper spacing, proper loops. Spark plug wires, we want to maintain a 1/4 inch spacing between our spark plug wires. 70,000 volts, a lot of energy. We don't want there to be any chance of arcing between wires. It's all the detail that actually takes time. I will give you the stock ElectroAir smooth power answer. A 4-cylinder system, we would expect 2 days. A 6-cylinder system, we would expect 3. Either one of them could potentially leak into the next day, especially for a new installer that may come across something that they've done wrong. Unfortunately, we're all human beings and we have a bad propensity. We're all guilty of it. We look at a product, this looks simple enough, and we don't pay enough attention to the manual. The manual is an excellently written manual. If you follow it, and I know this from experience, had a young man, a customer up in Nebraska, had bought a system for a Husky, had a brand new A&P fresh out of school. He handed him the box and said, go install this on that airplane over there. Well, being a young man, he was very computer savvy. He took our thumb drive, stuck it in his computer, pulled up all the data, and did the installation. Took him a couple of days, and it was flawless. I kept waiting to hear back from the owner of the airplane, from the shop. Didn't hear a word. I finally sent an email to the owner of the shop. I said, hey, how did that installation go? He said, perfect, flawless. Customer's happy as a clam. The thing's performing like never before. And I said, well, that's awesome. And I can't believe that I didn't get one phone call. He said, Darrell, I got to be honest, I didn't put the system on. My youngest junior mechanic did it, and he did a flawless job. But the point of the story is he followed the manual religiously and did exactly what it tells you to do. When you do that, it makes things go nice and smooth. The other point that I will make here, and one of the things that we emphasize, come up with an installation plan. And this is where you as an owner can get with your installer and discuss the installation plan and know where the components are going to go before you ever take them out of the box. I had a call today. I had a guy, trying to remember the model airplane. I think it was a Cessna of some kind. He was a little tight on space. He had a lot of avionics installed. He asked if he could piggyback the map sensor on top of the controller. I said, absolutely, not a problem. He said, he immediately said, that's the only question I had. I'm good to go. That's all I needed to know, because that makes it work really well. Not everything's going to be fine. The manual gives you a lot of flexibility. We cannot, or when Mike and his team wrote this manual, they couldn't tell you mount point or part A in position B. We all know these airplanes are legacy airplanes, and there's no telling what's been put in location B. So we could not be that specific, or they couldn't. The coil pack, I think it was discussed earlier. Yeah, we'd like to see it on the firewall. It takes the weight of the system is in that coil pack. The closer we can get it to the firewall, the closer we are to CG. But there's a lot of cases there just isn't room on the firewall. My Archer is an example, and I ended up mounting the coil pack to the framework of the engine mount. Don't use tie wraps to do that. Use high grade MS 8L clamps, and that works just fine. So to round it up, the installation, a lot's going to depend on the experience level of your installer. A lot's going to depend on how involved you get in it. The other thing that I have found is during this installation, it's real common to all of a sudden stumble across something else that needs attention. And a lot of times people, when they get their bill, they find out, wow, that's way more than I thought. Well, they need to look at the bill a little bit closer. They also fixed X, Y, and Z while they were there. But again, we're looking at 2 days on a 4-cylinder system, 3 days on a 6. Hopefully that helps you out.
I can vouch for most of that. It took us about 9 hours to put the one into my plane, but we were also reinstalling a repaired engine. So we were working with a clean slate. I can show you that PowerPoint thing I did if you want, Mike.
Well, that might be good in a minute, Pete. Were there any other questions, CJ?
Yep, there are a couple of others. And Pete, thanks for getting that one ready. We might even want to come back since it's a little bit after 9, but Don had a real interesting question about spark plugs for the Magneto versus the electronic ignition system. He said he heard you say the gap is 0.035 for your system, and Mike had responded to that. Mike, do you want to just go ahead and provide your answer? And if anybody wants to jump in with other questions about the plugs before we go on to how the system fires, this will be the time. Go for it.
Sure. The question was spark plug gap for our system. Anywhere between 28 and 35 thousandths is good. We have a full line of plugs that we sell, that we supply. They're gapped already, and they're pre-gapped, ready to go with our system for 32 thousandths. I think the other part of the question was, do you change the gap on the Magneto side as well? And the answer is absolutely not. You leave those at 16 thousandths.
So if your Magneto side plugs are...
Go ahead.
Oh, just if your Magneto side plugs are in great shape, then you just leave them and you put in the new Tempest plugs that are going to your system, yeah?
Right. You'll either regap your plugs if you can. Aircraft spark plugs are hard to open up the gap. Or, and part of, I know what Darrell has done with the special is given some good pricing on both fine wire and massive electrode spark plugs that are already pre-gapped. And I recognize the fact that it sounds like we're trying to sell a little bit more stuff. However, the aggravation that you go through to try to open up the gap of a massive electrode spark plug, I can tell it on the weekend when my ears are burning. I say, oh, somebody's out there cursing me about having to open up gaps on spark plugs. It's a lot easier to just buy them pre-gapped and a way to go. The thing you want to be careful of is you want to make sure you don't rotate the electronic ignition spark plugs into the Magneto side of things and vice versa. In a conventional 2 Magneto system, if you look at the different different maintenance manuals, it's got quite an arrangement of how you rotate spark plugs around the engine. When you've got the electronic ignition system in place, leave the electronic ignition system plugs in their spot for the duration. They're going to be just fine, and just rotate your plugs on the Magneto side. The other question, I'm going to anticipate a question here because it comes up often, is whether or not we use a fine wire, do we prefer a fine wire plug versus a massive electrode spark plug? And the short answer from an ignition guy standpoint is it's an I don't care. The spark plug is providing us a gap by which we can throw high energy across and light a fuel air mixture. So whether it's a fine wire plug or a massive electrode plug, they both do essentially the same thing. If I switch hats now and I put my engine hat on, I would tell you that the choice or the reason for choosing a fine wire plug over a massive electrode plug really should be, you should be listening to your engine and let your engine tell you what it needs. If your engine has a propensity to carbon foul or lead foul, you will probably do better with a fine wire plug because there's less surface area there for any of the contaminants to build up and then therefore deteriorate the plug and the plug's usefulness. If it doesn't have that tendency, massive electrode plugs are just fine.
And Zach Grant actually on the question, because I was out there, we were talking annuals, mentioned that one thing that a lot of people do, especially because the pricing on these Tempest plugs is so good, is if you're installing this system, just take the plugs that you're using for your regular mag and set them aside. They're now your backup set of spark plugs for your regular mag. And then just, he's like, for the trouble, same thing you guys just said, for the trouble of regapping and the cost and time, just buy the Tempest plugs and put them in the electronic ignition side, and then keep your regular mag plugs as a spare set. You're going to be using them for your Magneto more anyways, because the lifetime of both the SureFly and the ElectroAir systems are, the lifetime of the engine. There is a question that I just brought up, which is, what is the lifetime of the system? Useful time in service and maintenance.
You want me to tell them, Mike?
Yeah, go ahead. I was just going to say forever, but.
I can tell you from experience, I still get phone calls from guys that installed the original Jeff Rose system back in 1992. And they call me because they've got a magnetic that's gone out. That's the common thing on that older system. The magnetic pickups would go out. We sell them a replacement and they're back going again. There is no life limit to the system. 28 years of ElectroAir being in business, and the original systems are still out there flying. I mean, the ICA is pretty brief. It tells you about the spark plug wires and it talks about the MTAs. And that's one of the points that I try to get across to anybody I talk to. This is not a throwaway system. It is designed to be installed on the airplane one time and maintained from then on. And the maintenance for the majority of it is on condition. It's either working or it's not. Spark plugs, obviously, we still need to maintain them. And again, spark plug wires, we'd like to see them replaced at 1,000 hours. It gives me an opportunity to sell some spark plug wires. But the real reason for the spark plug wire requirement, when you get a product certified with the FAA, they like to have something that they can put in the ICA. And Mike, actually, interestingly enough, the guys that Mike works with at the Chicago ACO are the same guys that I used to work with in the propeller world. Exact same people. I already knew them. The FAA likes to have something that's got to be replaced. And spark plug wires, I mean, it's kind of like your car. I mean, you wouldn't jump in a 20-year-old car that's got 20-year-old tires on it and drive cross country. Similar thing. It's just preventative maintenance. And obviously the world that I come from, the propeller world, it's all about preventative maintenance. On a prop, something goes wrong and you're flying, it's too late to do the preventative maintenance. And the only thing that keeps these airplanes flying, as we all know, two things. One is money and the other is preventative maintenance. So yeah, there is no life limit to the system. It's there for the duration of that airplane. Just like, I believe it was Robert talking earlier about the airplane that he bought that the system had already been installed on, and he was giving us his numbers flying over the Rockies. That system's still on the airplane. It's not going anywhere. And that's one of our big advantages over our competition. It is not a throwaway system. It's there for the duration. That's one of many advantages. Obviously, the biggest advantage is the performance gains that we're talking about, the fuel savings, the performance at altitude. That's all things that you're only going to get from ElectroAir. And it all comes from the combination of a high energy ignition with computer controlled timing and a long duration spark. And it takes a system like the ElectroAir system that's got a few more components to it, a little bit more cumbersome to install to achieve all that. And the ultimate decision is up to you guys. I mean, I'm a consumer too. And I choose to use the ElectroAir systems on my airplanes. Obviously, I get a pretty good price as a distributor, but I have no aspirations of using anything else. Our results have been nothing more than phenomenal. That's about all I gotta say on the life of the system. It's there forever.
So it'll be there forever. And so that leads me to an interesting question. We have a high time engine that in the 260B, and we're going to be installing the electronic ignition system in there. And do you want to speak to that? Because I kept being like, well, should we wait till we get the new engine, or should we go with the old one? And I think other people have the same question. Do you want to go ahead and talk to that real quick?
I will speak to it, because the first thing I'm going to tell you, and if your father's still on, I see Bernie's still there. You guys have been telling me you're going to buy a system for about 3 years now, and I still haven't seen the check.
That's because you wanted our system for all the other people. You ran out. We ran you out of systems last time.
We can get you taken care of, CJ.
All right, we'll call you tomorrow. Go ahead, Dad.
I will tell you this. We had an airplane recently in the Aero Club that I'm associated with. There's a Cessna 172, had an 0320 E2D, which is a great little motor. The owner actually called me, this has probably been about 1.5 years ago, and said, hey, you know, I've seen what you're doing with your airplanes and the ElectroAir system. I want to put it on mine. I've got 1,900 hours on this engine, and I'd like to get it to 2,500, and then I'm going to put a 180 horse upgrade on it. Is the system compatible with the 180 horse upgrade? Of course, the first answer is absolutely yes, no problem. And the answer to the other question, should you put it on a high time engine? There's no reason not to. So he opted to have the system installed at 1,900 hours. Long story short, they ran that engine to just shy of 3,300 hours, which didn't take long. I mean, this Aero Club's a busy Aero Club. The only reason they actually pulled the engine at 3,300 hours, the new 180 horse upgrade was sitting on the floor and had been for 6 months. And Kirk, the owner of the Aero Club, made the decision, 3,300 hours is enough. We've got a certain amount of liability with these airplanes. We've got young student pilots in them. We need to go ahead and change it. The engine that came out of there, at 3,300 hours, the oil sample was still perfect. They bore scoped it every 25 hours. The exhaust valves looked pristine, and compressions were all in the mid-70s at 3,300 hours. To me, it's a testament to the system and what it's capable of doing. And we can't make the claim that you're going to get longer engine life. We just can't do it. There's a lot of liability there. But in the real world, are you going to see it? More than likely. These engines are running much cleaner, much smoother. Like we talked about earlier, the reduced heat on your exhaust valves, that's a big deal. Exhaust valves are the #1 killer of a cylinder. So to directly answer your question, CJ, I would go ahead and put the system on now. The system is going to be the same system when you change engines.
Good. So if for all of us who install and then go to a different engine, how much of the installation survives into the new engine? How much of it's a reinstallation?
All of it survives. The only thing you got to do is, your spark plug wires are going to obviously be disconnected and laid over to the side. Mag timing housing is going to be removed and hopefully put somewhere safe so it doesn't get dropped or lost. New engine goes in, mag timing housing goes back in, you hook up the spark plug wires. The only caveat that I will put into that, if the big thing you got to watch there is timing setting. You need to make sure that the controller is still the correct timing for the engine that's going in. Mike's SDCs cover just about every potential make model of Lycoming and Continental. There are a few exceptions, and the exceptions are some older, mostly the geared engines. There's not enough of them out there to really pursue. The Continental side of things, the only thing that he doesn't have is the Gitso engines that are used in the 421Cs. I'm hoping that we actually get that system. It's going to be easy to do. That's Mike's decision as the owner of the company. So yeah, the system is the system. The only variance is if you're going from a Lycoming to a Lycoming could potentially be timing setting. The only other thing I can think of potentially is if you're changing from a small barrel to a large barrel spark plug. And that's just a matter of changing the hardware on the spark plugs. That's easily done. And while I'm talking about spark plug wires and hardware, if you've got a guy that's new to the installation, please let them know that I do have a video on YouTube that you can access either directly going to YouTube, type in ElectroAir spark plugs, it'll come up, or you can access it from Mike's website, www.electroair.net. I go through the procedure for installing the hardware on the spark plug wire. It's not difficult, but it does need to be done right. And we saw in the past that that's where a lot of mistakes were being made, and the video has been very helpful for a lot of people.
Yeah, no doubt.
Yep. And just a quick time check. We're at 9:22. So I'm gonna blaze through a couple of these questions and then just try to, if you guys have more time to stay. But I think we're gonna try to stop the recording at 9:30 to let just so everybody knows. Generally, Pete Morris and Robert Klein are up until, when we stop at 9:30 until like 11 o'clock to midnight to get these things spooled up so the recordings can go up. We're very, very grateful to the Zoom team in the background. They put in just hours and hours and hours getting this done and up. But back to these questions, this is why I'm going to kind of whip through. We talk a little bit about the switch panels and the twins, because the twin Comanches came without keys. They already have a switched ignition. And you guys have done something a little different before with the twins.
Well, you mean on the twin? You're talking about the twin Comanches.
Yes. Yep. Exactly. Because a lot of us goes from our keyed ignition to the switch panel when we install electronic ignition, and I said, well, what do we do about the twins in the last group buy special where you're like, we're going to throw in the switch panel? I'm like, but the twins already have a keyless ignition, and you had done something different for the twins that was cool for them. Do you recall what that was?
I don't recall exactly what it was, but what I will say is for you twin guys out there, just call me. I definitely work with the twin guys because you're buying two systems, and I get it. Just give me a call, and I will work you up the best deal I can.
Yeah. And actually, former ICS president Bob Cretney has just run his two engines without electronic ignition to 3,300 hours on each side. So these high time, smooth running Comanche engines or Lycoming engines like Comanches are not uncommon at all. He's actually just in the process of installing new engines for the same reason your school driver is. He's flying back and forth from Texas to Wisconsin every month. And he just thought, yeah, I've got 5 engines sitting here. I should probably put the new ones on. The other thing is, but that's very helpful about the twins. Can you talk about GAMI injectors with electronic ignition? For those that saw Steve L's talk, superb talk on engine health check in the Lycoming engines, Steve gave a really fascinating part of his talk about the spread in timing with plugs and how the GAMI injectors were supposed to kind of bring that tighter. But I had then asked you about, well, are these compatible with the electronic ignition systems, and what are the gains?
Well, the electronic ignition systems are certainly compatible with the GAMI injectors. I'm not sure what the gains are in the Lycoming engines by adding the GAMI injectors. It's I've got to believe they're similar to what they've seen in the Continental end of things. You have to remember what you're doing is you're taking the system, in the case of the GAMI injectors, and you're tuning it to compensate for the deficiencies in the induction system. So in other words, as the induction system will vary from the front of the engine to the back of the engine, you change your injectors to match those differences in the induction system. The more we can tune that fuel air mixture and get it closer to being optimal, well, a high energy ignition system just makes that engine that much more powerful. you're building up, and Darrell even kind of hinted at it, is every time you remove the weak link, what you do is you expose the next weakest link. It's been my contention for a long time that on these engines, the biggest weak link in these engines are the magnetos, are these old mechanical magnetos that really haven't changed much. Well, frankly, since the 1930s. You know, the coil energy output is what it is based on the size of the coil, in fact. As a side story, when the original manufacturer we used for our coils was the same one that built coils for Continental, Slick, Kelly Aerospace. And when we went and visited them, they asked me point blank, they said, "When are you guys going to do anything about these coils? These coils haven't changed design, and you know, we could do some more things with them by adding some more laminates or more iron content to it or something, and really kind of juice them up a little bit." By adding the high energy variable timed ignition system, you've now got a tuned ignition system on this engine that's now able to optimize the spark event to help optimize, and again, I'm going to sound like a broken record, to keep that peak pressure point where you want it to be. The gamma injectors help that same thing by compensating or by adjusting the fuel input to what the actual induction input is, and keeping that peak output in that spot where you want it. If you have too little fuel and too much air, or too much fuel and too little air, that peak output from the combustion event is going to move, it's going to change. But the closer we can optimize all of these things and get them specifically where we want them to be, the more likely we're going to have the outcome, the peak pressure as a result of combustion, in the exact spot where we physically want it to be in the throw of the piston, to be able to drive the piston, create work, create energy.
Go ahead.
So I quickly inject about GAMI and their operation. Mike and I guess a couple of years ago now, we spent a couple of days up there in Oklahoma with those guys, training them on the install of the ElectroAir system, and got a great tour of their facility. I owned a repair station for a little over 12 years, so I'm not easily impressed. I was impressed. Those guys are sharp. They're good at what they do. Got to watch them actually manufacture their injectors, watch them, how they set them up on their flow bench. John Paul is a great guy. He's the guy you'll deal with in getting your injectors set up. They're sharp individuals, all of them are. They do a
Very
great
sharp.
And then last couple of questions. I think I'm going to shut up now and just ask one question. Is there two questions actually? First, for everybody on the call, well, actually for you guys, you guys are engine hackers. Electronic ignition is the result of your engine hacking, but are there any other things that you would say, you know, we're all flying behind Lycoming engines, you know, 2 major models with all of our subsets. What engine hacks do you think we should know about?
I've got one, Mike.
What's that?
I said, if I understand correctly what CJ is asking, what other things can be done to these engines to make them even better? Is that correct, CJ?
That is correct. Yep. Comanche drivers are always all about, how do I go faster, higher on less fuel? It's just, we're always wanting that.
The ElectroAir system is obviously, in our opinion, the very first place to start. One thing that I will quickly mention is tuned exhaust. Tuned exhaust systems, definitely an advantage. We've actually had one of our Grumman gurus did a bunch of testing, looking at the power flow exhaust system, looking at the ElectroAir system, and did a lot of actual flying and measuring of performance. What he came up with, because he had a lot of customers asking him, well, which one should I do? Should I do the exhaust or should I do the ElectroAir? So he wanted a real answer, so he did his own testing. He came up with, his numbers were about a 3 to 7% improvement in performance with the power flow exhaust system. Mike, correct me on this if I'm wrong. I want to say that he showed about a 17 to 19% increase in performance with the ElectroAir system. Obviously, more bang for your buck with the ElectroAir system, but the caveat here is I'm a big fan of tuned exhaust systems. I have a powerful exhaust system on one of my 172s. The downside of that exhaust system, it's almost too good. With traditional two Magneto ignition systems, that's it. The exhaust system is sucking so hard and doing such a good job of evacuating those cylinders. It goes back to that EGT that I was talking about earlier. It will actually increase those temperatures. It's pulling the hot gases, and in the cases of two Magnetos, probably still some burning fuel across those exhaust valves. So what I tell my customers that ask me the question, do the ElectroAir system first, and then when you have the money, do the exhaust system. The reason being, there is a chance, and I'm not knocking the exhaust guys at all. They're good at what they do, but to really get the full benefit of their system, you need a tuned ignition system to go with it. Again, the main goal here to make sure that we're not putting too much heat on those exhaust valves.
Good deal.
Other than that, there's not a lot you can do to these aircraft engines short of going totally illegal and putting cams and high compression pistons, but that's for the experimental world.
CJ, I was just going to add what Darrell kind of intimated at the best legal engine upgrade I think you can get is our system, and I know that seems, coming from me, that's probably a little self-serving, but from what I see out there, it's the best legal advance. Now, if you want to talk about illegal things or things that are kind of off book and that you can tweak, that sort of thing, like Darrell said, they do a lot of stuff within the experimental world in terms of high compression pistons, all kinds of different ways of cam angles and things like that. Frankly, one of the things that you can do, it's not really legal and it's hard to do, would be just simply to index your spark plugs and to get the ground electrodes perpendicular to the fuel airflow across the spark plug leads. It's a common thing that's done in hot rodding world, and in fact, it's almost unheard of to not do it. But just that little change alone will make getting the spark to the fuel air mixture that much more efficient. We've talked about, and in different times, I remember being in a sales call with, and some of you may know him, Darrell Baldock up in Minnesota, an engine builder up there, been doing it for years. He kept asking me about how to adjust the timing on the ignition. And probably about the third time he asked me, and I said, Darrell, I said, I'm not going to tell you, because I'm not going to tell you how to hot rod the engine, which is really what you want to do. And you can hot rod the engine by adjusting timing and tweaking it and doing what the guys in the race car world do, but it's not necessarily legal. And unless you're really attuned or an engine guy, you can end up getting yourself into you can get a lot of trouble by having high CHTs and burning up cylinders and valves and that sort of thing. So we have to temper all of our hot rodding in the certified world with also what makes good sense.
Good answer. Thank you. It is 9:30. We're going to, I think, Pete and Robert, are we going to go ahead and, we keep the meeting up, but we stop the recording to let the spooling start to happen. If you guys are willing to stay and people have questions, I'm going to throw open the floor. There were a few that I had to skip over just for time. If you want to respond to those, or if there's anything that I didn't point out that you had not already responded to, but thank you so much for being here. Only you guys can do this just amazing presentation and teach us so much about how our engines work. Thanks.
From the sound of it, there's still a lot of more value to be had, so I'm going to keep the recording going.
Awesome, Pete. Thank you for that.
I'm here for the duration. Obviously, I can stand to miss a few meals.
Well, going back to the chat window for a second, and
I've got my water in my Air Force mug, so I'm good.
Well, and as we say, the great thing about these Comanche Zooms, it sucks not to be able to get together physically, but you can bring your own drink because we don't fly home from this one. So whatever you're drinking is fine. We approve. One that just came in. One really interesting question that just came in from Peter Simpson. You may have touched on this, but are there any manufacturers using the ElectroAir system OEM?
There are. They're the smaller manufacturers. In fact, I'm just typing up an answer to Peter right now. The Cup Crafters is one. American Champion is another one. Aviat Husky is one. We're OEM with Lancer. And then beyond that, we've had a number of ongoing conversations with several of the other manufacturers as well. I can't really would be inappropriate for me to disclose or to talk too much about how those conversations are going. Other than to say, I think they're going pretty good.
Cool. I'm going to summarize a bunch of questions and comments. People were curious. So, for example, David Howson from Australia popped in and he said, he asked whether we'd see the same kinds of fuel and efficiency and speed. Let's see. Do you expect similar outcomes and benefits as in speed and gas efficiency for the 260C injected engine? And obviously, we had Eric's question about the turbocharges. Can you just give a kind of a comment? Because obviously, we have the 180s, which are carbureted. Most of the 250s are carbureted. We've got the 260s, which are all fuel, almost all fuel injected. And then we finish in the 260C turbocharged versions of the fuel injected engines. By the way, are you approved in the 400s as well with their AC?
No. And I'm not sure if he's if he's on the Zoom meeting or not, but I've been having an ongoing conversation actually with a gentleman with the 400 who would like to use our system on his airplane. Unfortunately, we don't have a coil pack for an 8-cylinder engine in the certified world. We do have them we do have them, and we have run them, and we've run them very successfully in the experimental world on the IO720s. Frankly, it makes that engine sing. I had one customer that had a dual electronic ignition systems on an NXT racer with an IO720, and at sea level, he was getting 300 knots. It was amazing.
Whoa.
The approach that I offered up to him, and it's a long shot, to be perfectly honest with you, but the approach would be to use a combination of some of our certified stuff and our experimental stuff and see if they would allow one to go in place of one of the Magnetos. I think there's a strong argument that we could make with the FAA to have them accept that under a field approval and get it done that way. Beyond that, my inclination and my engineering resources to be able to do a 720, probably a long way down the road at this point to actually do it as an STC kit. And it's hard to justify just because of the numbers. I forgot the first part of your question. Oh, the fuel savings, fuel benefits, and everything else.
Yeah, kind of across the range. Sorry.
Yeah, very consistently, and it doesn't matter. And if we speak to the 6-cylinder engines first, whether they're carbureted or fuel injected, the normally aspirated, non-turbocharged engines, the fuel gains consistently are 10 to 15%. That 1.5 to 2 gallons per hour we quote is really pretty rock solid. And if we don't see it, and there have been occasions where we haven't, we really want to dig into that installation and make sure it was done correctly. More times than not, we find out there was a mistake made. The mag timing housing, for example, wasn't installed correctly. And as soon as that gets straightened out, then all of a sudden the airplane is performing really well. Fuel system problems. In fact, there's one that Darrell's working on a Bonanza. By the way, you guys are a lot more relaxed than the Bonanza drivers, just saying. There's a Bonanza that we're looking at that he put the system on and saw no benefits whatsoever. And as we started drilling into it, we've discovered that there's some fuel system problems. There are some significant induction leaks, if I remember correctly. A variety of things that just were not picked up or hadn't been picked up during the routine maintenance of this airplane. Beyond Darrell and I for troubleshooting, we have a third person. His name is Ron Cooper, who I refer to as our engine analyst. Ron has been building engines for 49 years now. He comes out of, actually was hot rodding back in the 60s and did a lot of work. He was in the Marine Corps, worked on F4s and shoot, it escapes me now, the other one that he worked on. And so has a lot of experience with systems and with engines and with thinking through all kinds of troubleshooting problems. When Darrell and I run into a situation where it's a head scratcher to us, we try to get Ron involved as quickly as possible. And he has discovered more things that are overlooked by mechanics than you can shake a stick at. And as soon as some of these problems get fixed, then all of a sudden everything falls into place and the engine is running optimally in the way that it should be. We often tell people when they're taking it into a new shop, we'll tell the new shop, go fly with the owner and go get an understanding of where this airplane is at right now and get yourself a baseline. And I would encourage you, anybody considering the ignition, make sure you understand what the baseline is of your airplane and then put the system on and see where the improvements have taken place. But consistently, we've seen on the normally aspirated non-turboed applications, that 1.5 gallons, 2 gallons per hour in a 6-cylinder, that's duplicated over and over and over again. On the 4-cylinder engines, again, normally aspirated, it's very common to see 1 gallon per hour fuel savings very consistently, and especially on the O360s and the IO360s. Turbocharged applications, the data has been a little bit more hard to draw out because it depends a lot on how they fly the airplane. I'm fairly confident now in saying that I would expect on a turbocharged application that you should probably expect about 1 gallon per hour fuel savings. You're going to see better performance the higher you go. Robert, who had talked about the additional power that he sees at 14,000 feet, that has to do with this very high energy ignition system not having to, frankly, not going through a distributor. Remember, at altitude, we start to lose our energy because there's arcing internally happening inside of that distributor, and that's taking away the energy that could be used to ignite fuel and air mixture. Him commenting at 14,000 feet, there was still plenty of throttle left. There was power left to go after. Our world records that we've participated in, almost all of them have dealt with doing high altitude operations. The Spencer, who went to 24,500 feet, he was still making 200 feet a minute in that little pits, if you can believe it, at 24,000 feet. And part of that, I think, is it had to be all just hanging on the prop, frankly, because I think it ran out of wing. But he just got to the point where he knew he had enough altitude to break the record. So the performance gains that we've seen is very replicated over and over and over again, especially in the normally aspirated applications. I hope that covered what the question was.
And then some. I'm opening the floor. I've actually got some other questions, but I'm going to shut up and see if anybody else wants to jump in with other questions. And if you all stay real quiet, then I'll ask mine.
I'll tell a quick story if you want me to.
Please.
We have talked again and again about the installations of these systems and doing it right. And Mike mentioned I call him Mr. Cooper. He's my hero. I've learned so much from that man over the past 5 years. It's been incredible. He's a remarkable individual. We had a situation earlier this year, had a customer over in Georgia, a doctor, had a Piper Archer, bought the system and had it installed by a big shop over there, a very well-known shop, and they couldn't get it to run right. And they called me, and we went through some troubleshooting steps, had them check a bunch of different things. One of the first things I asked them was, we are positive that the mag timing housing is set properly. Yes, we're positive. I said, now, did you actually witness top dead center on number 1 cylinder, or did you rely on timing marks? No, we witnessed it. This went on for about 2 weeks. The owner of the airplane was super patient. He had finally decided that he was going to have him put the Magneto back on it. He was going to have his son fly it over to us here in Houston to take a look at it, figure out what was going wrong. While they were actually putting the Magneto back on, the mechanic went to time the Magneto, and that's when they discovered the problem. Somebody had had the propeller and starter ring gear off at some point and reinstalled it incorrectly. The starter ring gear was actually off by 60 degrees. They did not witness top dead center. They relied solely on the timing marks of the starter ring gear to set the mag timing housing. So the timing was set 60 degrees off from where it needed to be. They corrected all that, fired it up, and has been singing like a sewing machine ever since. But when you ask the question multiple times and you keep getting the same answer, isn't that the definition of insanity? Doing the same thing over and over again and expecting a different result? That one had us scratching our heads. We just literally, Mike had sent down every component that could possibly be wrong, and they replaced all of them except the mag timing housing. Had they done that, we probably would have, well, may not have figured out what the problem was, but we finally realized what the problem was. Of course, a huge sigh of relief for me, huge sigh of relief for Mike, because they had 40 hours worth of work trying to get the system to run right, and it wasn't on us, it was on them. It kind of goes back to gotta pay attention. And the manual tells you, you need to witness top dead center and make sure that you're actually there. Did that spawn any?
Yeah, I have a question. So I have electronic tachometers. So of course they're taking the signals off of the P leads. How does that work with your electronic ignition?
What kind of what type of electronic tachometers are they?
CGR 30Ps.
Those work fine. The tach signal that the ElectroAir system produces is a 3-pulse, 12-volt half wave, and with the one exception, the horizon tach. And we don't do this part of it. It's the manufacturer of the equipment. They will know what you need. In some cases, it's plug and play. In some cases, you will need some type of a filter in there to make the signal work from the ElectroAir controller. Mike,
okay, I could talk to them about it. Yeah.
Mike,
also, sorry, go ahead.
Mike, did I cover that properly?
Yes, you did. Mm-hmm.
Okay. Also, I have another question on CHTs. So I believe that as you go up in altitude, your advance kicks in. You're going to get an increase in CHTs. What typically can you expect? And I know there's no normal, but what kind of an increase in CHTs do you normally see?
Mike, I would rather answer this question because you give them a bigger number than what I've actually seen.
Yeah.
In the real world, what I've seen is anywhere from a 10 to 15 degree increase in CHTs. Typically, we see that more under power and in the climb than we do at cruise. And one of the cool things, and I've had to learn a lot about engines over the past 5 years. I know a lot about propeller systems, and anybody has any questions about that, I'll be happy to answer. But I remember from my early days, my grandfather was a 30-year career Air Force man. He was a mechanic by trade. I started turning wrenches with him when I was probably 5. And he used to tell me it's fuel to cool. More fuel is more cooling. With the ElectroAir system, we can actually do just the opposite. You can go on the lean side and actually achieve the cooling that you want to see. But more importantly, on that lean side, we're still maintaining power. And this is a question that comes up a lot. And this is something that we see a lot in the real world. And I've had to learn more about CHTs and what they are, what they represent. I've had to learn more about EGTs and what they are and what they represent. One of Mike's dear friends, who now I consider a dear friend of mine, a guy by the name of Bob Menace, he's a Continental engineer, was the lead of the team that developed the top flow induction 550. I've had multiple conversations with Bob, and one of the biggest questions that I had for him was, let's discuss CHTs, and I want to hear your opinion of what optimal CHTs are in cruise. His answer was pretty quick and to the point. He said, Darrell, I want to see between 375 and 385 in cruise, which kind of surprised me, but that's where he wants to see them. He said, at those temperature ranges, you're not harming the cylinder, but more importantly, you're keeping everything that's flowing through that cylinder in a gaseous state. At lower temperatures, it gives you the chance to have things cool to a point where they're going to solidify and attach themselves. He also told me that 400 plus in climb, he's not concerned about. He doesn't want to see 450, but over 400 in climb, not a big deal. He doesn't want to see 400 in a continuous operating range at cruise. But yes, the CHT thing is a question that gets answered a lot, and we do expect CHTs to go up. And it's simply a function of more work being done in the cylinder. We're doing a much better job of burning that fuel that you're paying for in the cylinder where it's supposed to be burnt, as opposed to letting a portion of it get burnt in the exhaust. And again, to kind of run full circle, that fuel still in a plasma or burning state, as that exhaust valve opens, that's a very bad thing for your engine. It's really important that we have that fuel in a gaseous state at a much cooler temperature coming across that exhaust valve. Hopefully that answers the question for you.
Yeah, no, thank you.
My pleasure.
You know, in Steve L's engine health check presentation, actually, this just brings up something that Steve mentioned. He said engines that run lean of peak seem to stay much cleaner, and he showed photographs of and Steve was one of Mike Bush's mentors, and but where Mike Bush is known as a Continental guy, Steve's really a Lycoming guy, and he's a Comanche driver, and he showed how lean of peak operations resulted in this beautifully clean looking engine after several thousand hours, and that it was cleaner than the richer peak engines. So it seems sort of compatible with what we're discussing now.
Well,
just threw it in there.
Steve also has an ElectroAir system on his airplane. Steve is a great guy, by the way.
We are pleased to have him among our Comanche drivers, I'll tell you that.
He's another one of my go-to guys when I have questions and things that I don't understand. And likewise, he'll ask me questions about props and prop systems. Actually,
and I guess I'm gonna.
No, go ahead, CJ.
Well, just so y'all, we're down to just a few. Well, not a few actually, but I have asked Darrell. We haven't had anybody talk to us about props in any of the gatherings I'm familiar with, and that's strange because we've all got propellers. We spend a lot of money on them, and so I actually arm twisted Darrell, and he's going to come back and talk to us about propellers at some point in the future. So I just wanted to mention that because you expect an announcement on that probably in about 2 months, if Darrell's schedule allows.
Obviously, you don't spend enough money on them. Otherwise, I probably wouldn't have sold my propeller shop.
Darrell, we try not to.
The comment, a brief comment that I will make about propellers, and again, I spent 35 years in that industry. It's probably the most neglected piece of equipment on your airplane, and it really shouldn't be. It's something you really need to pay attention to. As long as that thing is out there spinning and creating nice cooling air to keep you cool, you're pretty happy. but I've seen the results firsthand of what happens when they do fail. Fortunately, the failure rate of propellers is extremely low, and that's a testament to how well they're built. They're really well engineered. But I have seen the results of lack of maintenance, or actually, and I hate to admit it, poor maintenance. Not every 145 repair station is created equal. Unfortunately, the general public or the flying public thinks that the FAA is this awesome police force making sure that everybody's complying with exactly everything they should be doing. Sadly, that's not true. Anybody can put a dog and pony show on for a primary inspector. And when the inspector's gone, put crap product out the door to increase their bottom line. And I could tell you the bottom line in the propeller world is not great. The bottom line in the entire aviation industry, as far as the maintenance side, is not great. I mean, if you can net 7% at the end of the day, you're actually top of the heap. We do it because we love aviation. We could all be working on cars or being engineers and at GM, where Mike is up there in Detroit, and make a hell of a lot more money than we do in aviation. We do it out of a love for what we do. But yeah, propellers, they're a very important part. And one quick thing I'll say about props, and interestingly enough, I was at a Commander flying in Fredericksburg a couple of years ago. I spent more time talking about propellers than I did ignition systems. But I came out of there with 25 airplanes and I sold 8 systems. I was pretty happy about that. But I ended up dressing, I think, 4 or 5 props while I was there, and showing these guys how to properly dress their blades, how to address nicks, and how important that is. One of the things that doesn't get talked about enough, everybody looks at leading edges when they do a pre-flight. At least they should. Look at your trailing edges too. There is chance to pick up damage on those trailing edges, and damage on the trailing edge is actually going to propagate into a crack faster than on the leading edge. And it's simply because the material on the trailing edge, because it's an airfoil, is much thinner. The analogy that I use, and I can use this piece of wire that I've been playing with all night. If you had a nice smooth piece of baling wire, I'm in Texas, so we know what baling wire is. It's brand new. You could flex this all night long, and it probably wouldn't break. But if we take and file a notch in the middle of that wire and we start flexing it, what's it going to do? It's going to break right at that notch. That's the same thing that can happen with a nick in your leading or trailing edge of your blade. Those blades are flexing way more than you realize in flight. And they're not actually just flexing in one direction. The blade is actually flexing in an S shape. Towards the closer you get to the hub, it's actually pulling back towards the engine. Obviously, the further out you go in the blade, it's flexing forward as much as a couple of inches of deflection in the tip from where it was sitting static. A lot of movement. You couple that with centrifugal loading. If you ever look at the centrifugal loading chart, it's scary. Once you get up to about 2,900 RPM, the load goes up exponentially. Mike's an aerospace engineer. He could probably graph that chart for you pretty quick. It's ugly. So high centrifugal loading on these props, which creates a lot of loading on the blade shanks. They're trying to leave that hub. They don't want to be there. They're trying to get out of there. So bottom line, take care of your propellers and they'll take care of you.
I think at this point, I'm going to kill the recording. We've been at this for 3 hours. And I think we got almost everything we need to get as far as the recording goes. The meeting will keep going, but the recording is going to stop. Thank you, guys.
Thank you very much. Appreciate you.
Thank you, Pete.